Okay.
There we go.
Button
Send it
press.
to my Discord.
Let's see if YouTube is picking it up. YouTube is picking it up. Okay, so we're live on YouTube. We're live on Twitch. Okay, let me do the announcements.
Okay. Hello, Freefall.
Hello.
Hello, Keeney. Hello, Armadan. Yeah, what are you doing here, Armadan? I don't know. How's it going?
It's a crossover episode. We're gonna launch the Justice League of software development.
All good, Armadan. All good. It's gonna be weird because I'm not the one streaming, so I'm gonna have to sort of remind myself that, so I just don't do whatever I do. It's not my house today.
Okay, check this out, Toggle. Check out my setup.
Oh, can I make this window a bit bigger? There we go. There we are. All right.
Basically, I have a shell script where I type my tweets and stuff. Got Zig or Rust? Questions? Ask in chat. I write, it tweets, it toots, it posts on Blue Sky. I don't know what the word is for posting on Blue Sky. And posts also on LinkedIn. And so
on LinkedIn as well.
On LinkedIn. Yes. I'm active on LinkedIn. Yes.
All right. Just got me copper. There we go. That's wonderful. Who's doing things on LinkedIn these days? Maybe that's more. Hello, Andrew. Maybe that's more. I don't know. It's yeah. I don't know anyone who's using LinkedIn these days. But then again, no one I know has a job, so it's all the same.
I don't know. Uh-oh.
I'm sorry, Log. It just it kind of when I did Sig, it kind of backfired. So Christoph saw what I was doing to the language, and he thought this language is now soiled. I can't deal with this anymore, and then he just wanted to swap, right?
You know what? It's like I'm trying to diversify my portfolio, and as a wannabe influencer, I just need to chase the waves. Where the audience is, I need to go meet them.
Exactly. It's not what you want to do, it's what you guys want to see. And apparently this is it. So very good.
Yeah.
Hello, Julia. How are you going? Oh, did you ever finish the did you have like a pegboard thing? Not pegboard. Oh, I see it in the background there. Did you ever do anything more with that?
I wanted to do more, but no, I ended up not doing that. I have still this dream of eventually implementing enough tooling to have a conference where the entire conference speakers are not presenting normal slides, but their slides are actually a program that flips those things. And so like their entire slide deck, it's basically a set of animations on a huge wall of those things. The problem is that
the sound's gonna be amazing when it flips, right?
Yeah, it's gonna be intense for sure. Also, the problem is that these things have huge power draws, so like you would need a location that is able to give you you know how like productions that are big enough, like when they have like big lights, they even have different sockets, they're like different specifications for like power outlets. So I think you would need to do something like this. So it's hugely complicated logistically, but it would be so cool.
I mean, I imagine something like the ones you have in the airport or train station when you get like that loud clacking sound as
Yeah.
they're flipped. That's very cool. Yeah, why not? Right? Why not? How many like conferences have you? Do you organize conferences or no? Yes, I know you do. Right? You've
Yes.
organized. How many have you organized so far?
Let's say 2.5. Well,
2.5.
two real conferences and then two half ones. So, here's the website for conferences, and I'll scroll down just briefly so people can see. Here, there's a list of events. There have been 3, so I'm gonna scroll back up. So I've organized a first we called it a meetup, but it was like a no, it was actually, was it single day or 2 day? I think it was 2 days, a 2-day event. But it wasn't like a full-blown conference. We had like a classroom, access to a classroom in a local university, and we had some talks, and I called it the Zig Milan party, where the wordplay was like LAN party. But then after that, I organized Software You Can Love the first time. Then we had one in Vancouver, and that one is like, well, the first thing in the Milan party was half of a conference in some ways. Then Software You Can Love Milan was a full-blown conference. Then Vancouver, which was a full conference, but it wasn't organized by me entirely. So I like helped out and participated in the organization. But like I said half, but I would say maybe 80 to 90% was done by Matt Knight, and who lives in Vancouver. So he was, he had boots on the ground and he could pull it off. And then we had a Software You Can Love in Milan again in 2024. So yeah, 3 conferences.
Right. That's 3 more than I've organized. So that's pretty good. do you enjoy doing conferences? Do you enjoy the stress and which clearly must be a thing?
Yeah,
right?
it's definitely super stressful. Yeah, for sure. I think that what you get from conferences. So what I get from organizing conference. Well, let me put it this way. Have you attended any conference?
I've gone to talks, but not really a full conference. No.
Okay, so I've gone to a ton of conferences, like an order of magnitude more. I've attended an order of magnitude more conferences than I've organized. I've been probably, I don't know, somewhere between 50 and 100 conferences I've attended. Because I used to work as a developer advocate, so it was part of my job to go to conferences, give talks, shake hands, chat with people. And so it's weird because like I don't think of myself as somebody who is like particularly social. I mean, software developers, none of us is particularly social.
We're just sitting here like expressing social anxiety in front of a camera. This is what's happening right now.
Yeah. And but that said, at the same time, I don't mind yapping about software, so I can do that, and so that's good enough. That passes as being social at tech conferences. The problem, though, that one thing that I ended up discovering is that I don't like most conferences because those conferences tend to be focused on certain ways of doing software that I fundamentally disagree with. And that way of doing things is usually made even worse. It's poisoned by commercial interests. So like, for example, there's this conference that I at the same time don't like at its core, but also I think it's probably one of the best conferences that I've ever been to. I've been there multiple times. I've spoken to it at it, and like it's a great conference in many ways. It's NDC Oslo. So NDC is a cycle of conferences. There's like a bunch of NDCs all over Europe, also outside of Europe. NDC Oslo is pretty big. It's expensive. If you want to go there as an attendee, you have to shell out like a couple €1,000.
Wow.
To attend. And then you have to pay for your, hotel and everything else. You know what? Maybe a couple thousand might even be an understatement. Let's take a look. What's the latest ticket price? 5 days. Early bird, regular. Let's do the regular one. Let's see what is this in euros? Yeah, a couple thousand euros. Okay. Yep.
I mean, I see you kind of go like, should I buy a new computer or spend 5 days with a bunch of people?
Yeah.
It's a tough choice.
But like, look at the video. Like this video is representative. It's huge. They have like 7, maybe even more tracks happening in parallel. They rent an entire stadium in Oslo, like a hockey stadium, and like it's very big. The problem though is that my impression is that these conferences, so when the ticket price is 2K, I suspect that, like, my impression is that most of the audience that you get is the type of audience that can basically get back 2K euros worth of value from the conference. And, yes, sure, attending a good talk that has some value, shaking hands, meeting somebody who, who's a minor celebrity that also maybe has some value. But for example, with NDC Oslo, my impression is that the majority of the attendees are basically consultants. They go there to do networking. They're not wrong. I mean, it's perfectly legit. It makes total sense. The problem is that I'm not part of that audience. I would like to go to a conference where I feel like there's like more daring, more interesting technical content. And NDC tends to be, it can have good talks, but it has good talks. But it also has a lot of like Microsoft centric talks. Like every time there's like, it's not exactly a Microsoft conference officially, but in practice it is a Microsoft conference. So they always have, let's see it. Let's look at the agenda. There's always like .NET something, Blazor, that kind of stuff. They really talk a lot about development methodology, the kind of stuff that, let's catch up with C#. They always have this stuff. Like room 1 is the big room, and they always keep it for Microsoft related stuff. Platform engineering for private cloud. How a unicorn migrated from in-house solution to Helm. C#, algorithms demystified, open telemetry, resilient by design. Again, it's not bad. Like if you're into these topics, like if you want to go watch a DDD talk, you can go do that. I wasn't personally not super interested. So this whole explanation just to say, if you organize a conference, you get a chance to set the tone. You choose the topics, you decide what's important, you decide what's not important. And that part is priceless because, again, I've been to conferences that I've liked, but most of the time, most conferences are a little bit too commercial for me. I want to see janky TUI stuff. I don't want to see DDD. So that's what you get by organizing conferences.
So what's the? I mean, I guess if you charge $2,000 for entry, you kind of get rid of all the people that don't have any money, they can't afford your product anyway, right? So there you go. That's already a power move right there. That's some kind of Andrew Tate reasoning right there, man. Like, get rid of the brokies. We just want the people with lots of money, okay?
But it's unfortunate. Yeah, it's unfortunate because then all the discussions, and I've had plenty of discussions. Again, it was my job to have discussions, and I when I went there as a Redis representative. So like, Redis developer advocate to be precise, but like I was there not exactly to sell Redis. As a developer advocate, you don't sell people on the software. You talk with developers, but developers don't make purchasing decisions. So you don't try. You don't even attempt. It's bad developer advocacy if you try to do that. So that's not what I was doing. But I was chatting with people on a topic that we're also interested, like people that do consultancy and do web dev, like in general sense, they're interested in Redis. And I don't know, even then it was good for the job, but like not much interesting for me. Oh no, is Borg still skipping messages? God damn it.
I can see the messages. They were all rude, so Automod probably got them. One guy saying good morning, definitely don't trust them.
Oh no. But this one got through.
So I mean, we don't know Preston, some sweaty nerd. But
okay, let me restart it. Yeah.
So did you sort of say that you don't focus on developers when you were talking about Redis and such?
No, I want to. That's what I want to do. And the fact that a bunch of people there were actually not developers, not pure developers, they were more like sales people. Like what's the technical term? What do you call technical sales people who don't want to say they are salespeople? You call them. Oh man,
I cannot think of anything that is appropriate to say on stream.
Solution architect.
Solution so a solution architect is a salesperson.
At least it was. Well, it wasn't just Redis Labs, but let's just say database companies, as far as I'm aware, called solution architect salespeople. Yes, well, technical salespeople.
I didn't know this actually. It's kind of funny. It's a bit bizarre, but yes. What Space Traders IO? What's that? Is that their API driven game, or is that something else?
A unique multiplayer game built on a free web API.
Yeah, if this is the one I'm thinking about, they kind of just made a game in the shape of an API, so you build your own interface to it, and yeah, it is that one. I actually like that idea a lot, and I realized that I liked the idea more than I actually wanted to play with the idea. So the idea looks so good, but when it's like, should I play with this thing? I'm like, nah, I don't want to. I would be more interested in building the concept than playing with it. What's it like though, Sogatome? Is it good? How many hours have you sunk into this?
Is this like OGame but APIs?
Yeah, and so you can have like a front end for it, or you can build your own front end, and it's basically just trading in space. And I guess you don't really have sort of animations and fancy space combats and stuff, but it's kind of I think it's a cool concept, right?
Have you ever played? Have you played much OGame, Toggle?
OGame?
OGame. Has anybody in chat played OGame? Oh my god, don't tell me that this is an Italian-only thing. No, I think I'm getting Italian results because I'm... Holy shit. Okay, I thought this was... Wait, are you... Okay.
And they seem to have localization there at the top.
At the top... they have other...
No, sorry. I meant in the URL.
Developer Gameforge. It's a German company. Okay, so this is not Italian only. Oh yeah, okay. Bitwatcher knows about it. Yes, huge time waster. So Bitwatcher definitely knows about this. Well, you know what? I'll try to go to OGame.com. Second main result. Okay, domain doesn't say anything. What's the
you could buy that? It was for sale.
It still gives me the Italian version though. Like
I think you have to change did you change the URL? Although we're all fluent in Italian, of course, right?
Yeah,
we can do the hand gestures. So
I went to lobby.ogame.gameforge.com. So this is giving me an English result, but then when I click, they have
but if you look at the URL now, it's kind of attached IT_IT to the URL.
EN_US. Let's go.
There you go. Perfect.
It worked. Okay, so this game, there used to be a time. What ENGB? I refuse, dear sir. I refuse.
It would be interesting to see if the spelling is different, though, right? If they've done actual localization for all these languages.
I don't think so, but let's see. Expand it. Wait. I don't see any difference.
Nothing pops out.
No, I think it's an alias. Nothing. Well, maybe some other explanation, some other page, but not this one. So this game basically, it was, I don't know what to call it. Like, would you call it like an idle game, basically?
Well, I used to play something like this I think it was called a Utopia, and there was a few of these back in the day. They were just browser games, but that was before we had browser games, right? Before things like tower defense in the browser was a desktop tower defense. Okay. Before that was a thing.
Let me tell you what was the most like quintessential OGame thing. So you tell me if anything that you played was similar. So in OGame, the game loop, the basic game loop is that you like own a planet. So you're in a server and you own a planet, and you have other planets near you that are going to be empty. But then some other star system, either close or far away, will be owned by somebody else. You start by gathering resources locally, which happens automatically. Like you have to click like start research, and then research takes 2 days, and so then you come back 2 days later, and it will be done. And same with accumulating resources. But then you get to a point where you start building an army. And then at that point, what you want to do is kind of conquer other planets. But it's also more complicated than this, because when you have like an army, like you have a bunch of spaceships, I think they exist stationary on your planet. And so sometimes somebody else can come and deliberately crash your entire army, not with the intent of conquering your stuff, or more than conquering would be plundering. That's what happens. But they sometimes just want to crash your fleet so that they can collect all the debris. So they will literally, and keep in mind, this is all happening, how can I say, this is all based on timers. So what you do is that you send your army to your fleet to attack, and then you calculate how long it will take for resource collecting ships to arrive, because they have different speeds. So after a while, you send the collecting. Actually, you start by sending the collector ships because they're slower. Then when they are like halfway through their journey, you send your army to obliterate the enemy fleet. That happens, and then the collector ship collects back all the resources, all the debris from both your dead ships and their dead ships. But the thing is, if people are online and if they're refreshing the page, they will see at some point that they have an army coming in. So what your normal strategy would be is that you to defend yourself, you put all your resources in like treasury ships, and then you send those ships on a round robin loop. Basically, you send them on a journey so that when the other fleet arrives, there is nothing on the planet, nothing to plunder, nothing to destroy, and then the army goes back, and then your ships come back to the planet afterwards. So to mess with people, you wake up at 3 a.m. in the morning to set this stuff up. That's how it was. That's how it was. Like, okay, Bitwatcher, have you ever woken up? Like, what was the craziest time that you woke up on purpose to mess with people in OGame, since you seem to have heard about it? I outed myself already. I've woken up at the weirdest times.
Well, I think this is similar to that brand of games where you have like a set number of moves you can do per day, and then you have to wait the next day. And so I wouldn't call these games really idle games in that sense, because an idle game is a game where you kind of run the game. This is more like you play it for like 5-10 minutes while you're waiting for your code to compile or whatever. Yeah. And then you sort of look at it again the next day because not a lot happens, right? Does that mean The Voice, Neurogolf? Is that it? The Voice? Or something like that? I don't know. My German is really bad. The Portage, you played something similar. You had a planet in some solar system owned by other players, but your solar system was like your team. Yeah, that sounds familiar. You had like teams in these things as well, right? But it was a long time. All right, tribes. Yeah.
Oh, yeah. So yes, you could also do in OGame like guilds, I believe. And yes, there is another one where is it this one? One where basically it's the same thing, but it's actually like Roman. Travian. Yeah, no, that's the one that I had in mind. Oh my god, Travian. Yes. By the way, I'm using the overly Italian pronunciation because this is what I was used to call these things. Maybe it's Travian, I don't know. But yeah, I never played this one. But I believe this is the same concept as OGame. Oh my god. Yeah, such time wasters, man. This is older generation brain rot. Yeah, but
it was very limited brain rot. It's like when your parents say you're only allowed YouTube for 1 hour, right? It was like the controlled brain rot. So for that reason, I think it was pretty good. Speaking of like brain rot, did your parents ever tell you that you shouldn't watch too much TV because it's bad for you, whatever, right? And like, but did it really have an adverse effect on us? And now we're telling our kids like don't watch too much YouTube, but are we just being our parents? Is watching a movie the modern read a book now? Is this how it's gone?
I don't know if it had a bad effect on us, but I think it's funny that if I think about it, I don't watch TV anymore in the pure sense of watching like national, television with a set program, while my parents still do. So that's kind of, I don't know, funny to some degree. But I also think that the worst we could see, like the worst brain rot that you could find on TV, is not comparable with the hardcore brain rot that you can find nowadays. Have you ever seen Spiderman content on YouTube, Toggle?
No, this is new to me. I live a very sheltered life, so please educate me in Spider-Man content.
Say everything that you have to say about this stuff as I fetch you some juicy Spider-Man content. Although you know what, 1 sec. Let me go grab my cup of tea. Like 30 seconds, even less, and then we're gonna go Spider-Man. If anybody in chat has juicy Spider-Man content, feel free to share it. I will screen it first so that it's not too extreme, and then we can take a look.
Okay, I'm quite excited about this, right? Because I don't, I know what my kid watches, and she will watch videos that aren't too far away from what you'd watch in an office in sort of 2008, right? Like cats doing funny things or whatever, right? And she watches a bit of Minecraft content as well and Roblox, and that's sort of it. So I don't know, right? There is no bubble effect. Browsing channels on the TV is like TikTok. I think there was in the day you had to kind of wait for your program to turn up, right? You couldn't just choose what you want to watch. You get to watch what was on the telly, and that was more like, I don't know if you had like 3-4 channels or whatever. You don't have a lot of choice back then, so it was very much more like be outside and play more than anything. All right, I'm very excited about this Spider-Man con. So this Spider-Man con, this is what qualified brain rot. Let's have a look. This is what it's come down to.
Yeah, let's see. What is Andrew's link? Spider-Man. All right. Okay. No, this is nothing. No. Here's what I'm talking about. So this is actually one of the better ones.
What? What is this, like a game or?
So basically, this is a guy that has a VR sandbox game where he can load like models with ragdoll physics, and his own character can do Spider-Man stuff, and basically he like enacts these scenes where he's doing stuff. Elsa is his wife, Gregory is his son, and like he keeps doing weird stuff.
This is some kind of messed up divorced dad revenge fantasy.
Yeah.
And there's no sound or anything.
Oh, you don't have sound. Sorry. That's on me. Let me see if I can do something about it.
I mean, this dude obviously has some kind of family issues, right? Because this is not where your mind goes, right? What's the first thing that comes to mind when you think of Spider-Man? Divorce, anger, depression. This is what it's come down to, Rishi. This is what the world wants, right? We're now reaction streamers to Spider-Man content.
Yeah.
And Poor Gregory, man. Look at those dead eyes, man.
Yeah. So I tried to also give you access to that audio, but I don't think I can, unfortunately, with
That's
what we're
fair
using.
enough.
But yeah, basically the guy is just saying "Gregory, me boy" and like telling stuff to him. You can see that in the subtitles, but there's everything. There's everything. It's a Spider-Man pool
Is it
party.
always like? Does it always become like violence towards the wife and the child?
Yes, the wife is cheating on him constantly, and he has fights with people, and there's a bunch of violence everywhere. Yes,
I feel like there's a lot of deep-rooted issues in this, or maybe not even that deep. I feel like they're very close to the surface at this point.
Yeah,
right?
there's a trope. Let's see, where he, like scenes set in the city tend to have. Well, yeah, he keeps throwing Gregory off the building and then try to save him.
I'm starting to see why Elsa got custody over Gregory at this point.
Yeah, but there's also a bunch of ones where basically he keeps finding out we are wife pregnant. Let's go. He keeps finding out that Elsa is cheating on him at the top of a building, and then he throws her off the building.
That's when I find most of my life revealing experiences as well, on top of buildings. You're beautiful, and then he keeps slapping the child as well. It's like there's definitely. I mean, I feel like I almost want to have a conversation with this guy, just sort of a casual conversation. It's like, what was the inspiration for all this stuff, right? Where do you get your inspiration
also,
from?
this one has the twist. He changes perspective, and now he's Gregory. So now you see things from the perspective of Gregory, and now Gregory is watching stuff on a phone.
Oh, and Gregory sees dad die because
Yes.
that will show Gregory. Oh my God, there's like this. I feel like this is gonna be great source material for like first year psych students, right? They be consuming this content and be like, all right, what can we tell about this guy? And does anyone know how we can help Gregory in real life, right? Because I think Gregory's snooking at this point, right? Good grief.
Yeah, this is so bizarre. Julia, this is nothing. This is one of the best ones, comparatively. There's other ones, like, let's see, Spider-Man, animation, loop. Like, the problem is that they don't even have these things in their actual title. I know that they exist, but their titles make no sense because they're designed to be, clicked by 6-year-olds or something like that. But there's another,
yeah, that makes sense.
Yeah, there's another family of videos that are kind of like this. They're basically, so you might find this interesting. It's like a handful of set scenes that usually revolve around fart jokes, pooping, peeing, having to be in bed. Like there's this one where the Hulk, for example, has to go to sleep and be in bed, but he's actually on his phone. And then at some point, the door slams open, and it's like Iron Man maybe checking on him, and like he immediately goes and fake that he's sleeping, and then the door closes and he goes back on his phone, and it happens like a few times, which I guess it's relatable for maybe the kid, like the 6-year-old kid, right? That's watching that. He's actually doing the same thing in real life, so it's very relatable. But the thing is, here's where it becomes interesting. Those scenes are procedurally generated, so sometimes it's Hulk in bed. Some other times it's Iron Man in bed. Why do you know so much? Yeah, good question. I shouldn't. I don't know why I do. I don't know. Look, somebody has to, okay? Somebody has to warn people.
I was going to say, as an organizer of events, you have to know these things.
Those are basically my talks. There's... You come to stuff so you can love. It's like one talk is gonna be Spider-Man and Elsa on stage, trying to resolve their marriage problems.
And Paul Gregory's in the audience, but don't let him get near me, Daddy. No, Paul Gregory. That was beside. Now this is a new world to me. I have not seen that. So I remember when my kid was smaller, she would watch like these really messed up videos sometimes, and we stopped her from watching that though when we found out. But it was like for some reason Elsa from Frozen features in a lot of these things, and in this case it was Elsa getting surgery, and it was probably a little bit like this, but it was not when YouTube Shorts didn't exist at that point, right?
Yeah.
Wow, there's some kind of the Hulk is feeding.
This is one of those. This is procedurally generated. So you will see these go in a loop. So they have these live streams that keep running all day. They go in a loop, and the characters keep cycling.
So people actually stream this content.
Yeah. Oh,
and I guess we are right now, but there's someone who's actually streaming like the generation of this content, and that's I mean, why do we even try, right? Like you spend like days thinking about software to write and all these things, and meanwhile some guys just sitting there watching Spiderman do a shit, and that's like somehow it's like 60 million views. It's like, why? Why do we're doing it the wrong way, Krista? We need to change the content that we're streaming. Okay.
Yeah, we probably are. Let me share with you another one. Oh, this live stream is no longer available. Let's see. Is there another one?
And I don't know who the person to the right is though, but she needs to have some kind of endoscopy or something, because whatever comes out there is purple. That was not right.
I think I'm ruining also my YouTube like history.
Oh, I've ruined mine the other day.
So there's another one where there's another genre. By the way, okay, we're getting more close to like stuff that's interesting also from a programming perspective. Let's see if I can find that other one. So the one that I'm saying that said that I typed "don't say noob." This one, I think the live stream is not online anymore. Let me see if I can.
How's it going, Rizbus? If you like Sig Showtime, you probably like Spider-Man videos, right? Making money for Cenotaph. There you go, right? Yes, I ruined my YouTube algorithm. I have my own algorithm. I ruined my YouTube suggested videos the other day. So there's a guy who's been recommended on my stream a few times called Dave. It's Dave's Garage, right? And I was never really interested in this stuff because it was all way too many LEDs, right? But I actually watched some of his content and I found them quite fascinating. So I don't like so when you sit down and watch quietly on your own, it's very different from when you're watching something on stream, right? So I watched some of his stuff and I thought it was quite interesting. And that's how I got into trying out Ollama and DeepSeek as well, because he had some videos about this stuff. And I thought, this is probably quite easy to set up then, right? Because some guy on YouTube did it. No, but because it was looked like it was going to be reasonably easy to set up. So I tried that, I set it up, I played with it, I watched some of his videos, and now everything I get is recommendations featuring DeepSeek R1. But they're not interesting, informative videos. They're like, DeepSeek R1 destroyed the US economy. DeepSeek R1 forces NVIDIA guy to buy a new jack. I don't know. It's like all these non-related things. So I think algorithmically, the YouTube algorithm is kind of bad because it's not recommending things that are relevant to you. It's recommending things that are somehow related to what you watch without knowing what part of it that was interesting to you, right?
One thing that I found mind-blowing is that I think that Twitter has a better implementation of shorts than YouTube, which is hard to believe that Twitter has a good implementation of anything, especially recently. But I would invite anybody to try this out and see how pure is the brain rot that you get from YouTube versus shorts versus what you can get from Twitter videos. Twitter shorts, basically.
So do you reckon that Twitter shorts are sort of better quality-wise than content-wise than YouTube shorts?
I would say they're more varied. There's more variety, but more importantly, the implementation is better. Like I've had experienced so many bugs on YouTube. For example, YouTube recommending the same stuff cyclically. So like it keeps recommending the same things over and over and over. And then at some point the feed stops. Like the feed kind of reaches the bottom, but it's not really. It hasn't. There's no bottom. It just
there's no.
Yeah,
it's endless, right?
Yeah, it just has backed out. So I don't know. I don't experience that from Twitter. Again, it's like, I don't know. It's like, which flavor of poop do you think is better? It's both poop on either side. But
I mean, we did see some purple poo earlier, so I don't know, man. I feel like YouTube kind of got something going for it there. But YouTube really is. YouTube is kind of insane when it comes to streaming, because you want to stream on Twitch and YouTube, and YouTube has like zero discoverability. The chat is terrible, as you told me the other day. So for those of you who don't know, YouTube's chat is pull, not push. And let's just let that sink in. This multi-billion-dollar company is implementing chat the way we did it in the 90s. Okay, that's pretty insane, right? So there is really kind of insane how the whole thing works. Don't share no cookies now, yeah?
Check it out. This is the polling happening right now.
That's the live chat. That is absolutely bizarre, right? So yes, there we go, right? That's YouTube. But yes, YouTube is absolutely terrible for these things, right? So I find it difficult. There are some streamers who sort of went, I'm not doing the Twitch thing anymore. I'm going to YouTube instead. I don't know how that worked out for them, because I never saw them again. But that's not related. It's just because I don't spend too much time watching live content on YouTube, because it's impossible to find, right? It's really difficult to.
I think some people have made it big on YouTube. I think some people who maybe went on YouTube first and like grew on YouTube, but probably you need to have like a good also YouTube video presence. Like you can't just do live streams, I suspect.
No, I think you're right. You probably has to have something. You have to have like a community attached to it as well, right? And there's someone in my Discord who's not clicking. They just keep saying the wrong thing. Okay, right. All right. Okay. So okay, you know what? I wanna bring this. I'm so used to having my own like OBS and such on the side, so I can see how long we've been going for. Because I usually take a while to sort of warm up. You're gonna stream for a while. You don't want to expend all your brain cells the first 5 minutes.
Yeah, I mean, we're gonna get to programming, but you have to go through the brain rot first. No,
you have to watch Gregory fail in life because of his unfortunate situation with his dad before you get to do any programming.
Toggle, like, while you pointed out that there's like there's stuff that you can see in the storytelling about the author.
Definitely.
Yeah. If you watch enough of those, you would like it. It's like there's like all these subtext. It's like a second story. It's a story hidden behind the story. It's amazing.
Maybe that actually could make this something like really fascinating. You kind of you do an analysis and understanding on what is actually happening with the person making the content through the content, instead of just looking at the content for what it is, right? So you kind of try to follow the thread. In the case of Spiderman, it was a very short walk to get to the finish line with that one, but it was interesting. So we did a few conversations back and forth about things when it comes to programming. I'm gonna see if I can find. I'm just gonna get rid of everything. Squirrel brain here. So where our comments are, I'm looking where I incoherently have just said things in our chat there, right? So we one of the things I want to talk about, which I never really got to, was how uncomfortably large I am on your screen right now. But besides that, I want to talk about the allocators in Zig. I think that's a good place to start, because some of you who are watching this, you're coming from the world of Rust, and Rust has custom allocators, but only if you squint really hard and you're willing to do a lot of hoop jumping, right? So in general, you're going to be using the global allocator that is set up for you. And you can build allocators on top of that, of course. And I know there are people who do that. You have arenas and bumps and stuff, but it's nowhere near as convenient as it is in Zig. So do you want to tell me what different allocators you have in Zig?
Yeah, sure. Let's go. I'll have to resize you back to normal size.
I was too large. I was uncomfortably large there.
So I guess one way of exploring this stuff would be to let's go to the docs. And yeah, we're actually gonna talk Zig. I'm sorry. I know that I'm disappointing all the 6-year-old viewers in chat who wanted to see more of Spiderman and Elsa.
we've been returning with more Spider-Man and Elsa later. Take your bets whether CPA will, what are they called? CPS will take Gregory into custody or not. So Scott wants to know, what do custom allocators really give you? It gives you more control of the allocation strategy, right? So right now, when you're using something like a garbage collected language, you don't have to worry about any of that at all. If you're using Rust and a vector, for instance, then every time you push into the vector, when there's no more space in there, it's just going to give you twice the amount of space in a new, not a new vector. It's going to allocate under the hood. It's going to give you more space, and then it kind of just grows exponentially like that. Yeah. But when you do these allocations, what is actually happening is you take all the memory, and then you find a new place that can fit twice as much content. And then you move the stuff from your current location to the new location, and then you add the new stuff on there. And this is involving quite a lot of work. It's not something you're going to notice. If you create like 100 strings in your program, you're not going to notice this. But if you're doing this in a loop that is basically the core of your program that's supposed to run as fast as possible, then so let's say you're mining Bitcoin or doing something other useful thing, right? Then you want this thing to be as fast as possible. So it might be advantageous to not constantly tell the computer to go and find me more memory so I can put this thing here. Instead, if you can just reuse memory and such. So now that we know like the basics of allocations in Rust, if we look at how we could do this in Zig, we could use a different allocator with a different allocation strategy depending on our needs. We have more granular control. So take it away, Christoph.
Yeah. Okay, so my plan is let's do this in this order. Let's take a look at what's available under std.heap. std.heap is what contains a bunch of allocators. At least currently. The standard library might change in the future in Zig, will definitely change in the future in Zig, but currently this is the place where you go shop for allocator implementations. Let's scroll through them. Maybe some will make more sense than others. Doesn't matter. After we take a look at them, let's maybe try to write a simple program that uses a couple different allocators, and then we try to inspect the different behavior of the program using tooling like strace, which means that when we do that, I'm going to switch to Linux because macOS tends to freeze on me when I try to use those tools.
Strace, for those of you who don't know, is how you can look at the syscalls that are being made. Yeah. Basically, when you tell the kernel, but you're not allowed to do this. Your program is not allowed to do whatever you want. So you have to ask the kernel for some information like allocate memory, open a file, and these kind of things, right? So that's what we can see with strace.
Okay, let's see. Let's see what we have in this namespace. So I'm gonna go back to types. Let me see. Do we have? Yeah, let's go values, functions, and then let's look at types afterwards. So values, we have C allocator. Supports the full allocator interface, including alignment, exploiting malloc usable size if available. So for an allocator that directly calls malloc and free, C row C allocator. So C allocator, basically, it's a handle to malloc. And this thing is literally like a, think of it as importing from a C header the malloc definition. Well, row C allocator is importing malloc from a C header. C allocator is taking that and giving it a interface that Zig likes so that you can use it as you can pass it as a Zig allocator, because malloc, even though it's an allocator, it's a C function, it doesn't implement the Zig interface. So basically this allows you to, let me put it this way. if you have a C library that you're using, and that library is allocating memory using malloc, and then you as the user are supposed to free it, then you can use the row C allocator to free it, or this interface. Like, you can treat it as an allocation that came from malloc because, well, this is malloc, so you can free it with malloc. Another important thing is that if you have like 2 allocators, you can't allocate with one and free with the other, because the same allocator that you use to allocate is the one that you have to use to free, because basically it's a bunch of bookkeeping that needs to be synchronized. And like, if you use another allocator, that one doesn't know anything about that pointer, so it will error out. Page allocator is the one that gives you pages. So it's, I would say, page allocator for most use cases is your bottom allocator. So like, everything starts by getting pages from the OS, and then you can have more granular use. So yeah, page allocator is basically what mmap is, or what virtual alloc is on Windows.
So can you say a little bit what a page is for those who are new to allocators? I'm new to allocators. Yeah. Can you tell us what a page is of memory?
Yeah, you know what I can do? Maybe I can read you about pages. What do you say? Let me see if I can.
Now we're getting a peek into your book again, yeah?
Yeah. Let me see if I can close this other thing. Okay, perfect. Let's see. Yeah, I'm going to scroll down to virtual memory. So what is virtual memory, I guess? So to answer what a page is, we need to answer what a virtual memory is. So virtual memory is an abstraction built on top of physical main memory, so RAM. Before virtual memory, a memory address would always point at the same physical location. So a pointer with the value x4000 would always refer to the same byte in memory on the same memory chip. Well, this is not actually true, because I think that memory chips, like mapping of, like if you have bugged out memory cell in a RAM stick, I think your BIOS can unmap it. So like, there's some base layer configuration that can remap these things. But setting aside these error correction system, generally speaking, once you have done the setup, it's always the same mapping. The problem with this system is that programs have a bunch of offsets in them. Have sometimes references to locations in memory that are absolute. So they expect something to be at address X. And so that means that then if you have 2 different programs that both think that they have control over address X, then you can't have both of them loaded at the same time. And this used to be a problem in the past. Like, this used to be like a real problem. And so people try to find a bunch of solutions to this. One is, for example, don't use absolute offsets. Don't use absolute address, use relative offsets. So instead of saying address X, say 4,000 bytes forward compared to where we are now, that kind of stuff. But there's limits with what you can do. And so, for example, people at some point had to reinvent relocations. So the idea that the program, before it can be loaded, it needs to be pre-processed, because certain absolute addresses need to be recomputed base, starting from a base address. So basically, so that those relative offsets turn into absolute, but the base address, like the offset, can be changed, and so that allows you to load 2 programs at the same time in memory. Like, these are like super boomer problems that we don't have anymore, in part also thanks to virtual memory. So over time, a bunch of solutions were invented, culminating in virtual memory. Virtual memory allows programs to act as if they have the entirety of the computer's memory at their disposal. Physical memory is divided in chunks called pages, which are usually 4 kilobytes, although not always. Lately, apparently 64 kilobyte pages have become more popular, or at least like, if you get a new Raspberry Pi, what's the latest one? The 5, I think, Raspberry Pi 5. That one apparently defaults to 64 kilobyte big pages. The more you know.
So that means every allocation you make, you're going to get a minimum of 64 kilobytes.
Yeah.
So even if you just want to allocate 2 bytes, you're going to get 64 kilobytes.
Yeah. If you're using the page allocator, if you're using mmap or virtual alloc, then yes, before you would get 4 kilobytes as your base unit. So you could get multiples of 4 kilobytes, and on that Raspberry Pi, it would be multiples of 64 kilobytes. The reason for going with bigger pages is so that there's like less bookkeeping to do. Like, it makes it if you need a lot of memory, it's not a bad idea. It like, how can I say, it makes granularity a little bit worse, right? But then you have fewer things to keep track of from the perspective
Everything's
of
going to
the OS.
be a trade-off, absolutely, right?
Yeah.
So it's about picking what makes sense, right?
So each page is assigned to processes needed, and the translation between virtual address and physical address is done transparently by the hardware whenever the CPU requests access to allocation of memory. Toggle, do you remember the name of the hardware component that helps you with that translation?
The name of the hardware component that
you probably heard of it.
Oh, can you give me a hint? Because I have been using computers for at least
Let's
10
see
minutes.
if chat remembers. It's 3 letters.
It's not the ALU. That would be the math unit.
Yes, that one does math.
MMU.
Yeah, MMU and TLB. Yeah, I think the TLB is what I was thinking of.
Okay.
Translation local-site buffer. So basically, the TLB is a cache for most recently used. Actually, I don't remember what the eviction policy is, but I think it's most recently used. It keeps track, basically, instead of so the page table is literally it's a struct in memory. So in RAM, as you boot up the process, you write down basically in memory a bunch of mappings. This virtual address goes to this physical page. It's a little bit more complicated than that because it's more like I don't know if tree is the right word, but it's a 2-layer or 4-layer hash map, not hash map, mapping. In any case, regardless of these details, it's in memory, and so it's kind of slow to access. So the TLB is basically it's a cache of most recently used entries. So that way, the CPU can more quickly do this translation without having to every time go and fetch this information from memory, which is much slower. The funny thing is that if you are the OS, every time you change the active page table, you need to remember to also flush the TLB because it doesn't happen automatically. Like there's an instruction to flush the TLB, and if you don't, you get funny problems.
Did you run into this recently with your meanderings into OS Dev?
Yes, I can. I think I can actually show you the source code. Let me see if I can find that part without too much trouble. Kernel TLB.
Just straight
do
up
have a reference?
Water, Daniel.
So swapping the active page is a CSRW. So let's see, CSRW. Let's see where we have mentions of this stuff. User entry. Here we go. It's this. I think it's this yield. I think this is where we are swapping the active page. And this,
I'm basing that on the comment on line 147 there.
147. Let's see what do I have there. Yeah, swapping active page table. And so here, I believe this sfence.vma is what ends up flushing the TLB, I think. Maybe I should also point out that this stuff is not the same across different architectures. So like I think the TLB is x86 lingo, and I'm not sure. I mean, there has to be a similar component also in other architectures, but it might have different names and work in different ways. So in this case here, I suspect that this fence instruction is also implicitly flushing the TLB. We can see if the book says that explicitly when you talk about a page table. Let's see. Mapping paging, switching page tables. Let's see, what does it say? sfence.vma instructions added before and after setting the page table serve 2 purposes. 1, to ensure that changes to the page table are properly completed, similar to a memory fence. 2, to clear the cache page table entries, TLB. So yes.
All right. So back to the allocator, right? So the C allocator gives you pages back. Was that it? Is that where we left off?
It's the page
Okay, good.
allocator. The C allocator is more complex. So the page allocator, which you don't normally use, only gives you pages. The C allocator has a bunch of machinery implemented in the C standard library. So it's C standard library code, but it's not part of the OS. It's user code. Just like it's implemented in there, you could implement it yourself differently. And that allocator does more granular bookkeeping. So that allocator will only ask for pages to the OS when it really needs to. And then if you like make tiny allocations using the C allocator, it will know how to utilize efficiently a page.
So it's an allocator on top of an allocator. So you have the page allocator. Is the page allocator always the root of all allocations? We're talking heap here, right?
I would say, let's say that for normal stuff it is. For normal stuff it is. But you don't get all your memory by calling mmap. There is some memory that you get for free. As an example, so global memory, for example, in your program is not memory that you need to ask for via a syscall, because your globals are part of your program. So when you create a program, so for example, here I have.
Did you name your OS Christos?
I did, yes.
How Italian? Christos. How religious and Italian. So, Chuji, I don't know C, so I wouldn't be able to look at your allocator and it would mean anything to me. I apologize.
Currently not working allocator. Full C, by the way. Why do you hate us? Why do you want us to read through not working C code, man?
I actually had a good time writing C the other day, but it was kind of like it was fun to do, but I don't think I want to do it a lot, right? Maybe just messing about with it just because it's interesting. In a sort of, I might offend some people saying this, but I kind of felt a bit like an archaeologist poking around with that stuff, right? So no offense. If you like C, you like C, right? You enjoy watching that train wreck, Andrew? I'm happy to hear that. Sorry, I do distract you a little bit, Christoph. Sorry, go on.
No problem. So this, okay, so you know what? Maybe this one is a bit weird. Let's do it with kernel.elf. Oh no, right. Yeah, we don't gain anything that way. Or not much. Okay, let's look at it anyway. So this is I'm using readelf to look at how the elf file of my kernel looks like, or what it looks like, structurally speaking. And this is, so elf is the file, is the executable file format that is used by Linux and a bunch of other things. Windows would have .exe, so portable executable. macOS has what's it called, Macho. But they all work this way. They have the file is like, it's like a JSON file. It's not JSON in syntax, but it's kind of like a JSON file. And so it's a map, and at the top level it has like text, and text contains. Does it contain strings? It does not. Text contains your machine code, like your program, the instructions of your program, like the implementation of main is in here as machine code. Then you have like data and RO data. RO stands for read only. No, now what goes in RO data? Yes, you guessed it. Your text, your strings. I don't know why they gave these names to the things, but
I guess like everything that is static would most likely go into RO data. So not just strings, but yeah.
Yeah, not just strings. But I find it funny that text contains everything except text. But
yes, absolutely.
So RO data contains global constants, but if you have global mutable variables, then they go inside either data or BSS. BSS is for, I think it's for zeroed globals. And the reason
I think BSS, if we talk in assembly, that would be the declared but uninitialized values, was it? Or was it the other way around?
I think it's for zeroed stuff. I'm not sure though. Maybe somebody in chat knows.
Someone who
more.
knows assembly, pipe up and let us know.
Well, you know what? I know somebody who can help us. What's in BSS in a ELF file?
It knows your name. Oh my god, we're done for.
So what's in a BSS? Contains uninitialized global and static variables. Okay.
It even gives you some code to play with as well, right? That's what I think, Oscar Allen. That is exactly what it is.
Oh, also zero globals also go in BSS.
Oh well.
They treat the same way as an initial global since they will be zeroed filled by the OS when loading. Oh. Okay, because
we have to trust someone whose name is BSS Start, right? I feel like they have to be either an authority on the topic or someone really will change their nickname for the occasion.
So this makes sense because the OS is going to give you zeroed memory. It's not going to give you dirty memory for safety reasons. Like it's not going to give you memory with random data from another process, which might be a sensitive process. So it will zero it for you. So I guess that's why it goes in there. In any case, I guess the point is when your program is loaded into memory, like literally copied from the hard drive into memory, then all your globals that you declare there will be memory that you have access to that is given to you by the OS right away without having to go first through a page allocator. So that's an example of memory that doesn't come from a page allocator from malloc or from mmap or virtual alloc.
So that is memory that is allocated on startup, but this is not memory that your program would have write access to, right?
Oh no, you can. Can you not? You guys should be able to have mutable globals in Rust, no?
You can, but it's such a terrible idea in Rust that no one really does it. It's one of those things that, and that's not because writing. Well, I mean, okay, start off with a lot of the stuff around Rust is built around multi-threading, right? Mm-hmm. Or not built around it, but it is making it safe to do multi-threading, right? The moment you have global shared memory in a multi-threaded situation, you completely snook it, right? You end up having data races, possible data races, right?
Right.
So global mutable state is heavily frowned upon.
So
right?
Because you don't have a nice way of borrowing and returning using lifetime's global memory, right?
No, because the lifetime would be static. So
right.
The moment you borrow it, right? Actually, that's not true. You would shrink the lifetime, but how would you have a thread borrowing? Like, how would you reason about the lifetime when you have two threads running at the same time trying to use the same memory? If you just have one thread, it's a different story, though, right? Yes, Andrew, thread local, but thread local is explicitly just for one thread. That is not in a multi-threaded context, right? So it's when you have two threads reading and writing to the same memory at the same time, that possibility, then you end up with corrupt data, right? But you can have mutable global state. You just have to be explicit about it. You can't just say, here's a mutable something rather. It either has to be an atomic value wrapped in a mutex, so you have locking, or some other synchronization primitive that prevents you from writing to the same memory at the same time from two different threads, basically, right?
Yeah, that makes sense. So but I guess my point is there is some memory that you can manipulate and that can be used as the basic, like the source of bytes to then create more complex allocators on top.
Right. Yeah. So what I said when I asked about that memory, that was really poorly worded by me as well, but we ended up having that long tirade, so that's fine. What I was thinking more as, if we have access to that memory, how can we build? We cannot build an allocator that can grow the memory.
Yeah,
because the memory is fixed in size. So your allocator around this BSS data or BSS memory, that allocator has to have all memory is finite, but it has to be you have to kind of know the end of this thing very early on when you start up the program. It's almost like a global stack, almost, right? If you think about it now.
Yes, what the allocator basically would give you is the ability, it's the bookkeeping, right? It's the ability to allocate on it free, and what you free then would be reusable in the future in another part of the program. Yeah, you would get that, but then you would not be able to grow that memory.
That's interesting. I never thought about using like a large chunk of pre-allocated memory in the in like that section of memory of the binary. I always think about memory as the stack and the heap, which is the same memory, and then the read-only data, which you can't write to, and then static memory. I never thought about that as something that I might want to use as a chunk of memory, right? So that is an interesting idea. Okay, so that leads me to then ask, there is probably an allocator that is targeting that in Zig?
Yes. The way it works, it's called the fixed buffer allocator. And the way it works is that it's not designed for global memory specifically. It's just designed to work on a fixed size buffer. So like it uses an array as its source of bytes, and then that array can come from global memory, can come from stack memory. Technically, it could also come from heap memory. Like you heap allocate a array of a given size, and then you use that as the baseline for a fixed buffer allocator. This last example is a bit weird because if you're doing heap allocation, then why would you build a fixed buffer allocator on top of it? I don't know. Maybe there are reasonable reasons to do so. I don't know. But in the other cases, it makes a lot more sense because on the stack, you can only use fixed size buffers, and in global memory also especially so.
So would a fixed size buffer also be known by another name?
You mean in another context? Could
I'm
be.
thinking about a bump allocator in this case. Would it be, yeah.
I think that there are like two aspects of it. One is the let's say internal memory management strategy, and the other one is let's say a more practical like public interface. So a fixed buffer allocator, inside it's a bump allocator or linear allocator. So it's an allocator that is not doing granular tracking of allocations. It just knows how much has been consumed. So if you ask it to free a previous allocation, it will not be able to do so. It will not be able to give you that memory back because it would require it to have a more sophisticated tracking of which memory is in use or not, right? Because you start having holes, then you need to keep track of all the segments that are free, the ones that are used. While a bump allocator or a linear allocator just keeps track of how much you consumed. And so you can reset it. Maybe you can free the last allocation, like the very last allocation, you can subtract how big that one is and bring back the, I don't know what to call it, like the water level number. But then you can't free something in the middle of it because that would require more stuff. But then the other half of what makes a fixed buffer allocator is that the init function, like the constructor, asks you for a slice of memory. So you could have, for example, a bump allocator. I would imagine, my guess would be that a general purpose bump allocator in Rust would not accept a slice in input, but it would probably build a bump allocator on top of page allocation.
You could. I mean, this is down to implementation, but you could, as long as the lifetime of that slice will outlive the allocator itself. So you'd have to, most likely, it would be a static slice of memory from somewhere.
Give me a name of a actual. What is it? Bumpalo? Does everybody use
Bumpalo? Is a yes, that would be one of them. So that one is probably not gonna work on a slice, given that this thing would probably allocate on the heap.
Yeah, well, I guess my point is, it's up to the creator, right, to create to decide which interface they want to, which specialization, which interface they want to give to things. So I could see maybe they have both, maybe they don't. Let's see. Bumpalo. Oh my god, I don't know how to read this stuff. Collections. Oh, so it has its own vec?
Yeah, so this would probably be, that vector is probably a type alias. If you click on structs in the bottom left corner there on the create items, there's possibly a vec there.
There's a vec macro.
That's a macro. Okay,
Creates
if you look
a
at that vec there, this is probably a standard library vector that is using the bumper list allocator. So if you click on the source button at the top, right under the word struct there, no, it isn't.
No, it's their own.
It isn't.
Vec.
It is their own vector. They
made their own vec. Okay, but let's go back to the Bumpalo interface. So I want to see constructors for bump. Where's bump? Bump. Okay, let's see. No drops. Example. Is there like okay? Let's see. New, construct a new arena to bump allocate into. Try new with capacity.
That would probably pre-allocate the capacity at that point.
Allocation limit. Set allocation limit. Reset. Unlock. Try unlock. Okay, so this Bumpalo is definitely not thinking that you might want to build it on top of a fixed buffer.
No, probably not.
Do you think there might be another one? Do you have a name maybe for another crate that might implement that?
Oh, I am not the right person to ask because I avoided this one for the longest of times. What is another one that works similarly?
Maybe chat knows.
I wouldn't allow to use Bumpalo allocator on stable. That's right, CAFC. You cannot do that now. CAFC, do you know any kind of allocator that would allow you to pass in a reference to the memory that it's going to use as a backing storage on creation? Maybe this is something that would be fun to create. So it wouldn't be complicated. Either you would allocate the memory up front, and then you would leak the allocation because it has to stay around for the duration of the program, or not really in the same boat as you there. Was there supposed to be commas to that sentence, Capsi? Otherwise, I am really unsure. But so yeah, I think that it would be sort of simple to build.
Yeah,
in that sense.
I think this crate is it. I don't know how popular it is. It's called fixed bump. A bump allocator like Bumpalo that internally uses fixed size chunks of memory. Other bump allocators like Bumpalo are optimized for throughput. They allocate chunks of memory with exponentially increasing sizes, which results in amortized constant time allocations. Fixed bump is optimized for latency. It internally allocates chunks of memory with a fixed configurable size, and individual value allocations are performed in a non-amortized constant time. However, a trade-off with using this crate is that you may not be able to allocate certain types of memory layouts if the specified chunk size or alignment is too small, blah, blah, blah. Let's see, you create a bump.
So this one...
Yeah, you state generically what the backing array is, right? So this is 128.
Yeah, so this isn't really an allocator. This is a homogeneous storage, right?
Yeah,
you can like only put item in there.
Yeah, it's like a pool. It's a pool of items.
Yeah.
So never mind. Our quest continues. Maybe you can't implement that in Rust?
I can't see why not. All you need to do is have the memory and then pass it into it. So it's gonna have to own the entire slice, right? So to pass in a slice doesn't really make sense, because why the question in Rust parlance becomes, why would you borrow this mutable slice when you could own it, because no one else can have access to it because you're using it? That's the kind of Rust parlance, right? The Geek Pirate sends a picture to you. Let's see what this is. There is a lot of allocators in here with various approaches. That's a lot.
But
these aren't really allocators. Again, so Slab, for instance, is homogeneous. Bumpaloo is not, I think. Typed arena sounds as a slot map is. So these aren't really allocators in the sense that you tell it to give you some memory or you allocate some various types into it. Rather, these are different ways of storing things in most likely contiguous memory, which again means it has to be homogeneous, right? So I don't think these are that, right?
So runtime tantrum, it doesn't sound advisable to create a big buffer on stack. Having a static buffer sounds like a possible foot gun.
A big buffer on the stack, I mean, it could be okay. It depends entirely on your program. Having a static buffer is probably fine, but if you want to do things like get a chunk of memory from BSS and you want to use that as your backing storage, then you can do so, right? And I mean, arguably, the only thing you're saving probably, right, is the startup time of your application because it's going to be pre-allocated, whereas with the heap, you have to request the memory. But once you have the memory, there is no difference in terms of you writing to memory, because that is what you do. You writing to memory, right? And before we get back to all the different allocators as well, I just want to sort of prefix this conversation with, if I don't want anyone to get stressed out by the fact that there are all these different allocators and you might not know which one is right for you. Most likely, the software that we write doesn't need to use these very specific allocators. You can probably get around with the equivalent to what is malloc and free for 90% of all the software out there, because you allocate some memory, use it, then you free it, or you allocate some more memory, right? It's only when you need a very specific optimization that you think about your allocation strategy, right? I mean, I'm saying this generically. In Zig, maybe you do spend more time thinking about your allocators. Do you consider your allocator for everything you do?
Yes, although these ones that we're discussing now are kind of specialty. So usually I would say in my case, the general approach is whether it should be a GPA or an arena. I would say when you're writing Z code and you care about performance, you want to consider an arena even first. Like, you should start by saying, is an arena good enough for what I'm doing? Because it's so much faster and it's so trivial to use. Like, it doesn't have all this weird stuff that you have to worry about. The only idea is my stuff gonna be fine to free my stuff all at once, or does it really need to be handled individually? If it doesn't really need to be handled individually, then an arena is gonna be super good, and it's actually gonna make it easier for you to manage memory, because you only have to worry about freeing stuff at one point in time, right? So it's a web server, you only worry, or it's a game, you have a game loop, you only worry about freeing the contents of the arena at the end of the game loop, or once you've done replying to the client in a web server. And so that is it's so trivial, it trivializes memory management. When you can't do that, then GPA. A stack fallback allocator, oh my god, spoilers. A fixed buffer allocator to answer runtime tantrum up here. I'll tell you when it makes total sense. Sure, you don't want to put huge arrays on the stack because it's going to be counterproductive. Yes. But, for example, in embedded devices, when you don't have an OS, you don't have pages, you don't have page allocator. What you have is literally you have the memory in the device available to you as a slice, as a buffer. It's a fixed buffer to you because that's all the, 64 kilobyte, 64 megabytes, whatever the memory the device has. So you use that as a fixed buffer, and then you build an allocator on top. And once you have an allocator on top of it, then you unlock things like vectors, and you unlock things like, which are array lists in Zig, and you unlock things like hash maps, because the hash map expects you to provide an allocator. So, for example, in that case, it's so nice. It's exactly what you want to do. you don't have pages, you don't have heap allocation, you just have all the memory in the device already available to you right away. And so that way you get access to the standard library without needing a specialty version of a hash map, because the normal hash map in the Zig standard library will work perfectly well with your different allocator.
So weird way of thinking about it. Why would you put it as if you're encouraging people not to learn to manage memory, use default slow stuff like malloc? I don't encourage people to not learn memory. That's you extrapolating that from what I'm saying, Caribbean. I'm saying in general, in programming, you probably don't need to think about every single type of allocation you're going to do, depending on what software you write. There's a counter argument that would say, do you write only assembly then, given that that is how you're going to get the most performance probably out of everything? You're conflating meaning into something that wasn't there. Right? I'm not saying that you shouldn't. This is the reason why we're talking about allocators, right? I'm not saying you should use only one allocator. I'm saying in the majority of programs, you probably don't need to think too much about the allocator you're making, because the majority of programs are just going to allocate some memory, use it, and then free it, right? Anyway, back to the allocators.
I think that this stuff is interesting, and there's no reason to be like adversarial about it. But it is definitely something that is a concept that is very well developed in the Zig ecosystem, that is probably not as, it's not unique to Zig, but it's something that I can see maybe other ecosystems care about less, or like think about it less. The general idea, as I perceive it, is this, and Toggle, feel free to chime in and like share your perspective and maybe correct what you think I'm saying that is not fair. But in general, in Zig, you care a lot about this stuff because you care about performance more than in other ecosystems. I would argue also in Rust. Not everybody. I'm sure that there's people out there writing super high performance Rust who care about performance way more than I do personally. But on average, there's also a lot of people who are using Rust as a more high-level language, and they care less about performance. In Zig, you tend to care about it more on average. And at the same time, you don't have RAI. You don't have the borrow checker. So coming up with simplified memory management schemes, it's something that you care about a lot, because you don't have the borrow checker, guarantee correctness for you trivially. So I think about my allocation strategy also in terms of overall complexity, not just for performance reasons. And so allocators become a very nice way of both getting more performance, and also not having to worry about freeing individual allocations at the right time when you can get away with it.
Oh, absolutely, so I don't disagree with that. I think that's right, and there are different ways that we can handle this as well, right? Especially when you take something like an arena or a bump allocator, right, where you allocate a chunk of memory, and you mentioned games, right, which is probably a good place where you rather use an arena because you're gonna load up a bunch of resources into memory, and they're gonna stay there for a long time. And maybe you load like a whole game level, and you don't want to do a lot of allocations and freeing memory during like the gameplay. That's what you have the loading screens for. You can dump all the memory and then load up another one, or however you want to do it. Right? I mean, it depends entirely on the design of the game, right? So in that sense, it does make sense, right? You can solve these by pre-allocating memory and just using that memory. I think when it comes to Zig, you have a little bit more granular control. You might want to have some stuff on the stack if it's like a lot of small things. And you don't want to, so the important thing is that it's not homogeneous, right? An allocator just gives you a way to store data, whereas things like arrays and vectors need you to store data of a given type. And that's where things differ a little bit in how you use the data, right? So you could, if you have like a game asset, you can store multiple game assets in one chunk of memory. You just don't drop that until you're done with it. That you can do. But having more control over the allocator is obviously advantageous. I will say that I don't think the majority of programmers, obviously, this is hard to debate because the majority of programs, I think, today are JavaScript programmers based on the market, and they certainly don't care. So that one doesn't make sense.
Yeah, no, I think they're not JavaScript programmers. I think more specifically, they are React programmers.
Oh, there you go. But funnily enough, there is a group of people who write games in JavaScript, and they have come up with different ways of having things that looks like bump allocators in JavaScript. They basically have these chunks of arrays where they store all the data, and then they sort of pre-allocate the data to avoid having the garbage collector do various things with it, right? But no, I think it's custom allocators are, and we're talking about custom allocators per situation, right? So you have a function that want to do something with a custom allocator. That is not really possible in stable Rust today. That is something that right now you can change the global allocator. You can change from whatever you have to Gemalloc, or you can write your own, but it's going to be a global allocator. So when you want to go and allocate some space for a vector, that's using that allocator. You do not have the same granular control.
And it's going to be a GPA style allocator. It's going to be an allocator that keeps track of individual allocations and then allows you to free them individually with the overhead that comes with that. Well, I guess the flexibility, but also the overhead that comes from that. In Zig, it's not uncommon to give to a function two allocators, an arena allocator and the GPA allocator. The GPA for long-lived stuff that needs to be tracked individually, and the arena as a form of like scratch buffer for intermediate stuff. Like let's say that you have to do some string formatting to print, to log to a file or something, then you use the arena allocator for that so that everything gets freed very quickly at the end. Because you don't want to allocate a single string and then free it with a general purpose allocator, one that has like granular tracking, because it's a lot of stuff, if you can avoid it.
No, that makes sense. I mean, this is actually something that I needed the other day. I was working on something that would store the strings in contiguous memory. And so there were certain types of strings. Some of the strings were pointers to strings, and some of them were the bytes that made up the string, and it all goes into the same storage. And to know how much to allocate for this thing, I wrote everything into a separate buffer first to know the size, and then I had to move everything into this thing. And that's unavoidable because you can't just write into the middle of a collection and then shift everything out when you have pointers into it, right? Yeah. I have to just go for 1 second. I'll be just a second. Hang on.
Sure. But runtime tantrum, I think, so this is an interesting point. Makes sense, especially for bare metal. It just seems like most public crates are very averse to unsafe markers in APIs, which is why such a crate is hard to find. I see. I get that, I guess. Once Toggle comes back, I'll bring up a piece of content that it might be interesting to explore this idea a little bit, which, by the way, I guess my point is that I think it's a valuable idea, and it has influenced heavily the way I program. And I think that you can get some good mileage out of it. So I think it's an idea that should be considered and explored a little bit if you want to widen your horizons and like level up your programming skill. That said, I don't think it's something that necessarily, how can I say, I don't think it should, I'm not trying to sell it to you as like, the superior way of doing things. I get it that if you have a language that has RAI and it kind of helps you a lot, deal with individual allocations, and you find that style easy for you to program in, then I don't know, go make software that way. Like if the alternative is you don't make software, go make software that way. It works. But I think that is, how can I say, I think it's worth looking at these ideas past the concept of safety or unsafety, past the cost of having to open an unsafe block to get it working. Because I would argue, like from my perspective, I would argue that it's worth it. Again, for me, maybe not for everybody. I get that, but at the very least, if it's a kind of idea that is not mentioned a lot in your ecosystem, then it's even more valuable to take a look into, and then you decide if you want to use it or not, obviously. But so let's wait for Toggle to come back, and we're gonna take a look. And also, I think the more important thing is, hey Toggle.
All right, there we go. Yeah, my kid's not well. She's got a fever, so it's not a problem though. Well, for me, I'm not the one with the fever, right? But so she's a little bit. But the wife is here. It's all good. So take it be right.
Give her Spiderman Elsa videos to watch. Helps with the sickness.
That's what we do in the meantime. Okay, but let's get so we talked about the different allocators, right? Let's get back into it. So we had the C allocator and the page allocator.
Yeah. So, but let me repeat one concept that I think it's worth clarifying to the max. Oh, now you've become a character from Star Trek.
Sorry. There we go.
So I guess the core point is this. There's a bunch of specialty allocators that they do weird things. But at its core, I think it's interesting to think of them as two main families. The GPA family and the Arena family. Where, or at least, you know what, that's terminology that we use in Zig. Maybe there are better terms that one could come up with. But the idea is that GPA is what malloc is what a global allocator in Rust would be normally, is the idea that the allocator has internally bookkeeping for creating individual allocations and freeing individual allocations. And then the second system is what is at the basis of arenas, which is you don't track individual allocations, you track allocations as groups of items, and you allocate them as you go, but then you free them all at once. And that tends to work well when you have frames, cycles of some kind. So I think that's the core understanding. And then all these other allocators, I suspect you can place always in one family or the other, and there's like no confusion. So
all of those allocators there are most likely, unless they specifically use the alloc function, they are probably all gonna do individual free of memory and the like, unless a compiler optimization is happening. But it's not something that is going to be intentional.
Okay, so with that in mind, let's go. By the way, on the idea of the value of freeing things, of handling things in batches instead of individually, there's also some interesting content out there. Yeah, that's what I had in mind. The Casey has a video on it, which might be interesting. Okay, let's go back to what we were doing. So yeah, okay, so we have a row allocator, we have the page allocator. Then we have a WASM allocator. This allocator is fast, small, and specific to WebAssembly. In the future, this will be the implementation automatically selected for GPA, General Purpose Allocator, when compiling in release small mode for WASM32 and WASM64 architectures. Until then, it's available here to play with. So let me see if there's anything interesting in functions. Okay, so there's more, like logging allocator. This is funny. This is basically a wrapper around. So allocators in Zig are built on top of one another. This is not unique to Zig. I would say that generally speaking, it's a good idea. You want to build your allocators that way to allow for composability. And so, for example, GPA is built on top of page allocator normally. And then arena allocator in Zig. So let's take a look at arena allocator maybe, since we keep repeating it. This allocator takes an existing allocator, wraps it, and provides an interface where you can allocate without freeing and then free it all together. So it gets built on top. And so once you have this interface, for example, what is it? Logging allocator, it's literally an allocator that prints out whenever it's allocating. So you basically, you use this for debugging.
I think this is literally the example of implementing your own allocator in Rust. If one looks at it, it's going to be some accounting allocator that counts basically how many allocations you make. And that's interesting that it's an actual allocator in Zig.
Yeah. It's for, I would say, it's for debugging. I would say more like debugging maybe performance than debugging the allocator. Well, then debugging memory problems in your program, because you would use other tools, I think, in that case. Then there's a few more. Let me shrink the window so that people can see. Then we have, I'll get it. Okay. No. Macros. Okay. Then we have stack fallback. Stack fallback allocator is, let's see, returns a stack fallback allocator using either a fixed buffer allocator on an array of size and falling back to fallback allocator if that fails. So this is an allocator that accepts internally creates a fixed buffer on the stack. Well, it depends on where you store this, but let's say normally it's going to be on the stack, and it's going to be up to a given size. And yes, you can't put gigantic stuff on the stack, so it's going to be relatively small. And then when you deplete that memory, then it's going to start using the fallback allocator, which can be something else, which actually technically could be another fixed buffer, for example, or it could be whatever you want. But like I would say, a normal use case would be that the fallback allocator is a allocator that uses heap memory. So the idea is that if you're doing something where most of the time you need to allocate very little, very small things, and you want that to be faster, then you use stack fallback.
What is the allocator type that we see on fallback allocator?
That is the interface. I guess that would be a trait allocator in Rust, I think.
Okay, so it's an interface. Yes. I don't think I got as far as to interfaces, so I never saw how to implement these.
If you want, we could do this. I could show you a few ways of doing interfaces in Zig.
All right, let's have a look at the declaration and implementation of an interface in Zig. Let's do it.
You want to do it? Okay.
Yeah.
Okay. Let me go to
Null Point is really excited about interfaces. There's two of us that want to see this, Christoph.
Okay. iFace.zig. Okay. We're going to take it easy, okay? So we're going to learn a lot about interfaces, okay? I'm not going to go straight to the most complex way. We're doing it for real. No joke. Is everybody ready? Spoiler, there are no interfaces in Zig. So let's talk about the core problem, okay? Let me put it this way. Let's say that my core problem is that I want to be able, let's say that I have this. I have person as a type. Person has only a name. Yeah, person only has a name. And then I have const dog, and I have another type. And dog has, what do we give dogs? Let's say that dog has, maybe dog also has a name.
I was going to say a mortgage, but a name is better.
Okay, mortgage. No, you know what? Let's give it an item.
No, don't do it.
A dog can have an item, which is going to be, I don't know, an item. And like a dog can, it's like Pokemon, right? So you can give it a berry, potion, I don't know. Wait, some dogs have alcohol, right? Was it like on mountain?
Oh yeah, they're Saint Bernard ones.
Yeah,
like they have some brandy or something, right?
Yeah, let's give it a brandy
or bourbon. Yeah, let's go for it.
Yeah, I guess you should say the potion is brandy, but in any case,
the booze hounds, man. There we go.
Yeah, okay. So dog can have an item, and let's say that both can speak, right? What do we call it? Like quip. Okay, that makes sense, right? So this person can speak, and whenever they speak, we print that they're a person, their name, and what they say. Let's do the same with dog. So dog can also speak.
Dogs are well known for the quips as well, so don't change that.
Okay, so dog has an item, but the item doesn't factor into their speech. For now, at least. So we have these two types. They're different, but they kind of can do the same thing, right? And you want to be able to kind of use them interchangeably, like use both of them to speak in a homogeneous way. And let's say that to do that, I'm gonna do that by trying, like, let's say that my starting point is gonna be, I want to be able to put them in an array. Like I want to be able to put an array, to create an array of things that can speak, and then maybe loop on it and make them speak. So let's try to get this working in the most naive way. So here's what I'm gonna do is I'm gonna say const, I don't know, speakers. That's actually how my conference works, basically.
Preferably no dogs at the conference, though, right?
Now, here's the first problem. I don't know what the type is gonna be. Starting problem is I need to create an array of things. I don't know what the type should be, but then in here I'm gonna say, okay, there's gonna be. Let me create them. So const p.
Yeah, I'm guessing you can't just whack a person in there as well because of memory layout, right?
Yeah, so that's gonna be our first problem that we need to tackle.
Okay, sorry, I'm not gonna jump the gun. I'll be quiet.
That's okay. So let's toggle bit, and then we're gonna have const. I'm gonna be a dog. What were the items? I'm gonna take some brandy.
Good choice.
Accepted equal sign. Yes. Okay. So we have this. There's already a problem because we don't know what to put there. Yes, this is the first problem. The first problem is that arrays, the way they are defined in like the concept of an array in let's say low level programming languages. Well, I guess in reality is that they have to be homogeneous. Every item has to be the same thing necessarily, because an array is based on the principle that all items have the same size, and then to move from an item to the next, you always move the pointer by a given number, a fixed number every single time. So you can't have arrays that are like dishomogeneous, or rather, when you have an array that has these homogeneous contents, it's actually either a struct or it's a buffer that you're allocating stuff on. So it's like it's a different data structure. It's not just an array. So yes, now here we have the problem that person and dog have different sizes, because person is going to be 16 bytes big, while dog is going to be bigger. We can actually test this. I can do this.
I'm guessing the person would be 16 and the dog would probably need, because of alignment, I'm guessing the dog's going to be 24.
So I'm going to try to compile log. Oh, and have unused local constants. Come on, man.
So it's not just me then, Christoph. It's not just me. It's 24. Yeah, I kind of guessed it would be 24 because of alignment, right? If you pack them together, it could have been 17. You just have the what's it called? The selector of the enum of the variant, the discriminant.
Yeah, this guy could be a single byte big. But then the problem is that you need to put padding in front of this struct.
Yeah, so you'd have to pack it. Right?
Yeah, because otherwise the math, like the reason, by the way, why a struct has padding is not because it's necessary if you have a single struct, but it's because it's necessary if you put them in an array. Because if this guy was, what we were saying, 17, then if it's 17, then yes, then basically the alignment would go out of whack when you have to put them one after the other in an array.
It's more cache friendly as well, right? And I think in some circumstances you can run into problems if your data isn't aligned as well.
Yes,
with the CPU, right?
Yes, some CPUs refuse to do unaligned loads, for example.
I think read unaligned memory or something like that is the error for that, if I remember correctly. But I haven't seen that in a long time, so I don't think any new programming language will deal with any of this stuff, right? All programming languages is going to have a sensible allocation strategy or sorry, a memory layout for these things, right? The interesting thing is the Zig does not have a stable memory layout either, does it?
It depends. For a struct, no, it's not well defined. So you can't assume that name is gonna be. Let's say that you have a pointer to a struct, right? So a pointer to a struct will literally point to these items, but you don't know if name is really gonna be the first field. So you don't know if name is really gonna be at offset 0 into the struct. If you want to have that, you have to do extern, which gives to the struct C style memory layout semantics. So if you do this, then you will know for sure the name is at offset 0. It would be correct to take a pointer to dog and reinterpret it as a pointer to names, to reinterpret it as a pointer to a slice, because that's what you have right away.
But the reason to not have a fixed memory layout, I imagine, for Zig is because you can now do optimizations where you rearrange the fields so you don't have to use excessive padding, which is so why is it 24 and not 16? Asks Frango Molado. Sorry, Frango, I mangled your name there.
So the way it's going to be is that it's going to be 16 for this, because this is a fat pointer. So it has 8 bytes for the pointer, the size of a pointer in a 64-bit operative system. 8 bytes for the length of this slice. That's basically a pointer and a U size. And then this guy is actually a single byte. I think that if you do size of this, you will see that it's going to be a single byte. But then after that, there needs to be extra memory with nothing in it, absolutely nothing of value in it. That needs to be there so that when you put two structs one after the other, you don't break alignment. Because without the extra padding, what happens is that if this were to be 17 bytes, then a subsequent struct inside of an array would start at offset 18, and 18 is not aligned with anything. Like it's not even aligned. It's not aligned at 8 bytes.
So that's and that's also like how memory is read is using offsets, and some I don't know entirely what I'm talking about now, but I'm gonna say things anyway. But these offsets has to be power of 2, I think, for the memory alignment, right? So it
depends on it depends on the type. So the problem is that this guy contains a pointer, and pointers need to be aligned at 8 bytes. And so here, for example, MLAG is saying the reason why this struct has this alignment is because this guy needs to have to be always aligned at 8 bytes. So like if we do the math, let's do a little bit of math, okay? Let's say that this is offset 0. At offset 0, let's say that we're making an array of 2 dogs, and this is going to be our offsets in memory. So at offset 0, we have the first dog, and that's going to have name, right? And name is going to continue from offset 0 until 16. So 0, 16, maybe let's do it like this. 0, 16 is going to be name, dog 0 name. Then we're going to have at 17, we're going to have dog 0 dot item. Then let's say that there is no padding. After that, we're going to have at, 18 to 20, 34. I think 34. 18 to 34. We're going to have dog 1 dot name. And then at 35, we're going to have dog 1 dot item. Now, the alignment of item is 1. So item can be placed at any place in memory, and it's going to be fine. But this guy, name, it's the pointer requires alignment of 8. So these types have natural alignment, like a 64-bit value. So a U64 naturally wants to be aligned at has alignment of 8. So it needs to be placed at an address that modulo 8 equals 0. And when it's not placed there, that is an unaligned memory access, which either means that the CPU will refuse to do it, or potentially it might need 2 instructions to do it, because some CPUs might not have the ability to do a load, an unaligned load. And so it might need to first load the first half of because if your number is unaligned, then it's going to be like across this boundary. So it will need to first load one part of it, then load the second part of it, and then do some math to mask and glue the 2 values together and produce the final value. So it can be done, but then it's like much more expensive in terms of performance. So this guy is what forces these alignment requirements. And what Amlag was saying is that if I force this to be align 1, so if I say, you know what, this is going to be a slice, but it's going to be an align 1, which, by the way, by saying that it's going to be a line 1, Zig will potentially generate different machine code to account for that thing that I just described. Maybe it will turn what previously with a naturally aligned slice, it would just be a load from memory. Like every time I want to read the access into a CPU register, I'm just going to issue a load word. Now it's going to be maybe load word X and then load word X plus 1 and then do the math. So that's what this information type system might imply.
So it kind of becomes a trade-off of performance versus memory usage.
Versus flexibility, yes. And so at this point, then this guy doesn't have this memory requirement anymore, and so it can actually be put in weird places. So with that in place, now you see that it's 17. And so but when this is not the case, then to make sure that a subsequent dog is in the right position, then you need some padding, and that's what brings us to 24. You need then 18 to 24 padding. Well, let's call it .0.padding. .0.padding, and so that way. Actually, you know what? I'm dumb. We should do non-inclusive offsets maybe.
No, listen, one saw or said anything, Christoph, right? No one. They all sat there, including me. Don't worry about it, man.
Okay, yeah.
This falls on everyone.
Let's do it like this. Yeah, since we're starting at 0, that's what we should do. Let's say dog item. So this is going to be 16 to 16, and this is going to be 16 to 17, and then this is going to be 17 to 28, and this is going to be 28 to 28 plus 16, 30,
46, 4.
44? I'll take your word for it.
Yeah, I mean, it's not like the numbers have matched up before anyway,
sorry,
so don't worry about it.
24 plus 16, 34, 40. Okay, so that's the idea. And then this is going to be 40 to 41. Okay, so the padding is necessary so that we can guarantee that dog name is always the starting address where it's placed, modulo 8, is always equals 0. That's the job of padding, guarantee that property. And this is also because, well, yeah, that's it, I guess. So, okay, so now we understand this. Now we want to put these guys into an array, right? And we can't because they have different sizes, and that's a problem. It's actually worse because even if they had the same size, that alone wouldn't be enough, because then we would have another problem, which is, you know what? Let's do it one step at a time. So how can we homogenize this? There are a few different strategies. Everybody was already shouting vtable in chat, but I'm not gonna do vtable. Let's take it one step at a time. There's actually a surprisingly flexible tool that you can use to create interfaces, which is much simpler than vtables. And want to guess what it is?
Something that is simpler than creating a V-table. So I'm guessing we're not talking about like type erasure here or pointer casting or.
No, we can't type arrays
Okay.
because even if we type arrays, so we can't type arrays because here we have literally the memory that is different, right? We are not placing pointers to these guys. So if we were to put pointers to things, maybe we could try to be clever about it, but we're not doing it for now. And by the way, that's maybe worth exploring later, but we are placing the actual value in the array, so they have different sizes.
All right. So we're getting tagged unions here, which in Rust parlance would have been an enum, which
Yes.
definitely would have worked, right?
Yeah,
Is that is probably the most sensible thing to do if you're not writing something that is a public interface, right? If you don't want other people to be able to add their speakers to this thing, that's probably the simplest thing you can do.
Yeah. Hey, Jim. Hello. So yes, we can create a tagged union. So let's do it. It's going to be either person or it's going to be a dog. Okay. So let's see if this works. Also, I don't know why I went for an uppercase letter. There are speakers. Okay, so for now, we are not getting any complaint from the LSP, but we know that the Zig LSP doesn't tell you the full story. So maybe we should try this out more. Let's develop the code a little bit more.
Let's iterate.
Yes. So for speakers, we're going to have one speaker at a time, and then we're going to do std debug. Well, we need to switch on the speaker.
You have the function. You have to switch, and then you can call the function on the.
Yeah. Oh my god. Okay.
The fun thing of doing these things live as well, right?
Oh, well, for me, it's always like this. It's fine. Okay, so we have, yeah, we're switching and
I did not proper bug. That does not sound like me.
Okay, let's run it. No field or member function name talk in interface.person because it's speak.
You got the wrong kind of dog, Cafsy.
There we go. Person toggle bit, hello. Dog glories, hello. It works. But that's not exactly what we wanted, right? What we wanted was to be able to do s.speak, right? That was our goal. And we can have that. The way it works, the way you do it in Zig is you just give a method to the union. So I guess I'm going to copy this just to have the signature. This is going to be s speaker. We still have the quip. But then basically what we do is that we switch here internally and we dispatch to the correct method. And quip needs to be parameterized. Quip. Okay. So now we can do speaker.speak and it works. Okay, this way we have runtime polymorphism because you can create an array of speakers and they can call into their concrete implementation. Okay.
This is very much how we would approach this in Rust as well. You'd have an enum with your variants would represent the various types. And of course the enum I'm guessing in Zig that enums have the size of the largest variant, just like in Rust. So we can do memory layout. And that's why this looks incredibly familiar and a good way of solving it, right? Okay. Let's see what happens when we move on to the next step. I'm interested to see where we're going to end up next then.
Yeah. So let me tell you that there's like there's one step further that we can take with this approach, which is kind of nice in metaprogramming in Zig. So you see how we're doing this very repetitive work of saying, oh man, yes, I need, in the case person, we're gonna need to call this. In the case dog, we're gonna need to call this, right? And they need to be different code paths, because even though it's called speak every time, well, actually, it doesn't have to be called speak, right? This could be speak person, and this could be called speak dog, right? They could have different names. It doesn't matter. But they are different functions. And so even when they share the name, they still are different functions. There's one trick that you can do in Zig where you use comp time metaprogramming to basically obtain these same semantics, but with just one line. And you do it like this. So you know how you can give an else branch to a switch? You can give a inline else branch to a Zig switch. And it's going to be, let's call it person or well, I don't know.
Speaker.
Yeah, I guess we can use speaker, although we are already using it for the general
Lowercase
union.
speaker.
Lowercase speaker. Let me think of, let's call it X for now. It's fine. So X, and then we do X dot speak quip. And this can replace all the other ones. Quipper. Oh, no. So inline else is basically, it's an else branch, but it's not just one code path. It gets expanded into a different code path for each concrete possible case of else.
Oh, so as long as whatever you have in there, it has a function called speak,
Exactly.
then it doesn't really matter what it is.
Exactly.
That's
it works.
Really interesting.
Yeah, it works because you can duck type basically on it.
So if you call the speak person and speak dog, it would no longer work because they would have different function names.
Yeah, different function names. It would be annoying. Or maybe you could basically create more metaprogramming machinery to reconcile those differences. Like you could even be evil. Like you could go to the extreme and say, you know what? I'm gonna take those types, inspect all their public functions, and search for the word speak in the function names. And when I find a function name that has the word speak in it, then that's the function that I will select. Horrible idea, but you can do it.
That's really cool. Yeah, I agree with you, Julia. That's very, very cool. Could you also access the name property on the X value there?
Yeah.
That is really cool. So this would look like a match expression in Rust where you would, as long as they're the same name and the same type. We can take this a little bit further in Rust. You would be able to have different names as long as you, in your match expression, rename them there. So what is on the right-hand side of the chunky arrow is effectively the same variable name and same whatever. That's really cool, though. I like it. That's very cool.
Yeah. Is that doable without switch? Kinda. You can do it with for. You can have an inline for that does something similar. So we went through this whole pain because we needed to do like a normal homogeneous loop. But if you are in metaprogramming land in Zig, you can do stuff like this, that it's like heavily duck typed. So you can do an inline for, and inline for can loop over a tuple that contains, let's say, toggle and loris. So notice how I'm creating something that it kind of, if you squint, it's kind of like an array because we're going to be able to loop over it. But it contains heterogeneous types. And so because this is not an array, this is actually a struct, and we're using metaprogramming to loop over the fields in this struct. The first field will contain toggle, the second field will contain loris, and then in here we can duck type to the max. So we can do, well, I haven't showed you the name example, so let's access name. So we're not gonna try to speak, that's gonna work, but let's do this. std.debug.print name. And then we can also do this. If at what is it? Has field. If has field, the type of s item tag name. You know what? Let's avoid also tag name. It's fine. It's not necessary.
Really? That
Yes.
is pretty funky, I have to say. That looks pretty fun. So you are basically doing this at compile time.
Yes.
So how does this work? Because if the input can't be dynamic, can it?
No, I can't. In fact, what I'm doing here cannot be done inside a normal for loop. It works inside this for loop because you write it this way, but what happens conceptually is that imagine that if the code was copy pasted twice without the for loop, and where in each version we replace s with the first copy paste, everything becomes loris.name, and in the second copy paste, everything becomes first one toggle.name and the second one loris.name.
So it's like monomorphization then, right?
Yes. Keep in mind, I'm saying conceptually because this is not messing with the Zig AST. This is not doing like textual replacement at all. It's not a macro, but conceptually if it's forcing the unrolling of that loop of that for and resolving everything that's known at comp time as it does that.
So this inline for, it has to be done on known values, and they have to be presented as an anonymous enum union.
Not necessarily this.
Could it be an array?
Yes, it could be an array, but it has to be a array that's known at compile time. So we could replace this with speakers. Well, the speakers contains unions, so it's different. But we could create a normal array. Well, also in this case, these guys are different, so you can't put them in an array. But okay, let's make something similar, but that works on speakers. Okay, so I'm gonna do it for real, so you can see like a real example. So speakers, it's an array that contains unions, right? Speaker unions. So in this case, I can do the same. I just need to let's do it this way. Const s equals std.meta.active tag. Okay, this is gonna be a bit cursed. This is gonna be a bit cursed. Okay, I turn this into equivalent code that works for our union. Let me try it. Let me try to compile it before I tell you wrong stuff. So yeah, let me fix this. Expected constituent found tag type. Oh, wait, does active tag give me to 1 second? I want to see if it gives me. Oh yeah, it still gives me tag type. Okay, perfect. Okay, it works. We made it work. So let's go through this insanity.
One confirmation here, right? You wouldn't be able to change const speakers to var speakers now, would you?
Let's try.
I in my head that can't work.
What do you expect? So it's complaining that I'm not mutating it. So let's do underscore equals speakers. So it stops complaining about me mutating it. What do you expect?
I expected that to not compile, because if you can change the things that are in there, then, I guess if it's an array of the same type, it does. Right. It has to be comp time known. Okay.
Yes.
Oof. Right.
I think that if Zig wanted to be super clever, in this specific example, it could say, well, you know what? This is a var, but you're also really not touching it anywhere. And so, fuck it. I'll consider it a constant, a comp time known value regardless. there's probably, it's a bad idea. Like I'm saying, in this specific case, in theory, maybe it could be done. Maybe there would be horrible consequences in doing these things. But yes, in general, because the loop is fine. No, yeah, the loop might be fine, but the bonkers metaprogramming, I'm not sure it is.
I was gonna say
think.
this feels very metaprogramming.
Let me see.
Doing
Actually,
this.
let's see. Field name must become time known. Yeah. That's the problematic part. Is there like a better way to get the active field? Yeah. Is there a better way to get the active case of a tagged union? Because technically this doesn't have to be this way, right?
Well, don't ask me.
Yeah, no. I like let me rephrase this. I know that this could be fixed. It's the problem here is that actually what MLAG was correctly pointing out is that actually most of what I'm doing in here could still work out. But the way I'm trying to do things, in this case, the metaprogramming doesn't work. So I would say there are still some metaprogramming things that you can do on runtime values, but as long as the moment that you depend on something that needs to become time known, then obviously it's not going to work for things that can change at runtime.
No, and the only way you would be able to do that would be to associate some additional data through the compiler to associate data with this thing. So you would definitely inflate the type and everything. Right?
Yeah,
so,
that would be runtime type information, and we don't have that. That's what Go and Odin do. Like Go has runtime type information. And for example, the JSON parser that you get by default in Go is doing a ton of runtime reflection to parse JSON. It's terribly inefficient.
Yeah, I can. So I don't really know anything about Odin. No one has voted for Odin yet on Language Tuesdays on my stream. So
yeah.
But speaking of which, I think we might be seeing Swift the week after next.
Swift.
But, it was very close.
Yeah, I was Swift gang.
That's very. I think instead like the worst language one, and I think that's kind of a given. It's the nature of Twitch chat, right? But this is really interesting. So this has this kind of meta programming that you do to do this, and
it's kind of insane though. So we're by the way, this in a sense is kind of the inverse of runtime interfaces, right? Here we're doing the opposite. We're doing monomorphization. Let's go back to the slightly less insane example, this one. So this one is doing this kind of stuff is the opposite of runtime interfaces. It's like you're resolving these differences at comp time. And as Emlag was saying, every time you see inline in Zig, well, not every time you see inline, every time you see inline in Zig, you should think copy paste. But especially for inline for and inline else and inline while.
I got a question.
Yes.
What if you want to inline a function, as in the traditional compiler inline this function? What is that?
That also looks like copy pasting. It's just that you copy paste once, in a sense. So
will this do inlining at a SIG level, not at LLVM level?
Yes,
or
it will do inlining at a Zig level. So the difference is this: when you use the inline keyword in C, that is a compiler hint. Like the compiler is not forced to even honor your inline request. And yeah, so I don't know. Maybe it's useful, maybe not. I don't know.
Is that true for SIG as well then? So inline, it's not. It is always forced when you do
it. Is forced. It's a compiler. If Zig can't inline a function for some reason, I don't know, maybe because it's recursive, it will error out. So inline is different. On top of that, there's a few semantic things that happen by doing inlining in Zig that are specific to comp time. It's a bit nuanced, so I'm not sure it's worth getting into much, but basically inlining a function has interactions with comp time resolution of things. Let me put it this way. When you call it, so Zig will not eagerly try to run your functions normally at comp time. So if you have a function that is a normal function, it doesn't declare its input arguments as comp time. Like it doesn't force you to have comp time known arguments, but you have an invocation where you happen to have all those values known at comp time, And so that function in theory could be run at comp time, but you're not explicitly requesting so. And like you're in the middle of your main function, for example, that function will not be computed at comp time. You have to ask for it. But if the function is declared inline, it will basically, again, conceptually, copy pasted into your main function. And so the comp timeness of the input values gets inherited by those expressions. And so they will get resolved at comp time in that case. It's a bit nuanced. But yeah.
So if you have two inline functions calling each other, which would then result in a recursive infinite recursion, would that be a compile error?
That would be a problem. So if they call into each other and they're recursive and they do so forever, that's a problem also at runtime. But if a runtime value if you know that the runtime value at some point will stop the recursion, then yes, they cannot be inline because that will not something that can be solved at comp time, and so they will be copy pasted forever in theory, and so that causes a failure.
So it will just reach like a recursion limit error or something like that.
That's a good question. No, I don't think it does that. I think it fails right away. Like I think as soon as it detects a loop, it will error out.
All right. Okay, that is interesting. That is one of those edge cases, I'd imagine, that you probably don't run into too many. So does this mean that functions are, well, I was going to say functions are normally not inlined in Zig, but if Zig doesn't, do you have generics in Zig in that sense that inlining and monomorphization happens? Maybe that's a weird question that doesn't.
So what is interaction between inline and monomorphization? So yeah, we have monomorphization in a bunch of flavors, right? So here you saw one example, which I mean, maybe it's debatable if you want to if this counts as monomorphization. Let's say with a non-overly strict definition of monomorphization, this should count. Like classic monomorphization in Zig looks like this. You have a function called let's call it list.
To answer Brian briefly, I think if you put everything into your main function as a result of inlining, the only thing you would really save on doing something like that would be creating and destroying stack frames for the function calls, which might save you, I don't know, a couple of instructions. But really, I don't think that there's any real benefit to doing that.
I think the general idea is that you should not use inline unless you know that you want inline, because the compiler can always decide to inline a non-inline function, while if you force inlining, then now you're restricting what the compiler can do. And so the compiler is not able anymore to choose not inlining. The way in which one becomes more preferable than the other is it depends on how much you're quote unquote abusing inlining. Like let's put it this way, as a baseline, inlining is a good idea. It's better to have, like, it's fewer machine instructions to do the operation right away rather than
a function call.
Yeah, rather than saving registers, calling a function, jumped into machine code that it's elsewhere that maybe the CPU doesn't even have in cache, and so it will need to be fetched from memory, and that's going to take a while. And then you do the operation, and then you have to do the teardown where you return back to the previous instruction, which maybe was flushed from cache, and then you have to restore registers and whatnot. But if you have a function that gets used a lot in a ton of different places, and you copy paste it all over the place, then your executable will become much more bloated, potentially, depending on how much that function is used. And executable bloat is bad, because the more your executable is bloated, the higher the chances that the instructions that it needs will not be in cache. It's a super high-level idea.
And if you have too much bloat, then your executable gets IBS and they have to go somewhere. It's a whole thing. But no one got that joke. Sorry. Okay. The thing with inlining, there's actually a dude named Matt Cladd who wrote a post about inlining But he does Zig programming now, but he wrote the post for Rust, which is kind of good read. And the general consensus is this, right? Now, can I say this without people going to accuse me of promoting bad performance, right? Don't worry about it. It's fine. When you, and the person who did that, please don't feel like I was being cranky with you or anything like that. Please come back. We love you. The inlining in general is not something that you have to do, because the compiler will do a lot of inlining for you. And I think this, now you have to correct me if I'm wrong, this can probably be quite heavily affected by setting your optimization level for a specific optimization. You can optimize for small binaries, for large binaries. You can do various different optimizations. So most people know it. All right, you guys are good. So yeah, but no one laughed, and the joke was clearly very funny. So I'm assuming no one understood it. That's how it goes. But yeah. So you're setting your optimization level will change the size of your binary and will change the inlining. And you can tell the compiler to inline never, inline always. Now I'm saying this. I'm coming from Rust, right? So there's the things you can say in Rust.
We have no inline.
That's the same. In that case, you can say this all you want, but the compiler might choose to disregard it. Where inlining, and I'm wondering if this is true in Zig, where inlining becomes important is also when you have third-party libraries, because you want to have, it might not be possible to decide on the inlining strategy for an external library as a statically linked library, at least, right? Maybe you can do this in Zig, I don't know, but in Rust, you cannot assume inlining if it comes from another crate, as they're called in Rust. So there you can say always inline this function no matter where it's used, because normally most functions probably would be inline, or a lot of functions would be inline by default, I'd imagine.
Well, if it's in some code that you don't control, so like if the function definition has not been written by you, then yes, you don't get the opportunity to put an inline keyword there. In Zig, what you can do is ask for a calling strategy at the call site. So if we go to the official documentation, there's a built-in called @call that you can use to call functions. So, instead of having the normal direct function calling syntax, this is like slightly more abstracted syntax to do a function call. The reason why we have this, well, think about it this way. This helps with metaprogramming because it allows you to create variables that reference functions. And so you can pass those around and you can put them into this built-in, because Zig doesn't have, right, the, what's it called? It doesn't have macros. So we can't create syntax that becomes a function call. We have to treat that as data. But the call built-in also allows you to specify things like normal function call. Let's ignore async for a moment. Never tail. Don't do title call optimization. Never inline. No async. Always tail. Always inline. Compile time.
Will this have any? So this call syntax there. Looking at that, made me think about testing. And does Zig have the sort of a version of do not optimize this code? Can you wrap code in something to prevent optimization when you're doing things like benchmarking, and so the compiler doesn't optimize everything away?
There are two ways. So there's one thing in the standard library that Android doesn't like, and that has to do with LLVM optimizations. I think it's do not optimize away. So we have do not optimize away. But what do not optimize away does is basically, I think it's implemented as a chunk of like volatile assembly.
Oh yeah, you mark it. Yeah, that sounds familiar. Also, Brian wants to know if well, he doesn't want to know if Zig has TCO. I want to know if Zig has TCO. And Brian wants to know what TCO is.
You know what? Actually, I'm not informed at all about the state of TCO. So maybe I would hope that mlug is still around. I can answer that one for me.
mlug, come back. We need you.
I can say what title call optimization is in general. I don't know what the state of it is in the Zig compiler. I guess the fact that it's in there, it means that it's expected to be there, but I don't know if we have it already fully working today. So in any case, do not optimize away adds a little bit of...
Wait. You never explained what it was.
Oh yeah, I'll get to that. Let me finish the previous thing. So the previous
sorry.
thing is...
Okay.
yeah, so do not optimize away is a little bit of assembly, right? To make sure that LVM doesn't like resolve your entire benchmark at compile time while compiling, and then like write down in the executable the final answer, basically making your benchmark moot. So that's or tossing a bunch of work away because you don't look at the result. So this is what do not optimize away does. But on a different level, we have another thing called set runtime safety. Can somebody remind me what's the optimization level changing built-in? I forget. I think it also changed name at some point, and that's probably why I don't remember what the new name is. Name this trap extern run.
Optimize for does not yet exist. Set runtime safety.
Oh, it's just set runtime safety. Okay. Oh,
I'm reading chat, by the way. I don't know these things.
Okay, so this is the only one that does change. So I guess then release versus debug mode optimizations, that kind of stuff is just at the module level.
So what would you do in the event of wanting to write some benchmarks, right? What would you use to make sure that your code, or would you?
Well,
can you not?
Yeah, no. What you want to do probably is do release fast, and then if you look at the generated executable and it turns out that your loop where you had a bunch of additions has disappeared and it has been replaced by the final result, then you put a do not optimize away in there.
Okay, so that's how you would do it. Okay, because I imagine a lot of like setup things can probably be optimized away. For instance, you're creating some vector or array of something, you iterate over it, but you never use it.
Yeah.
So that will probably be optimized away as well, right?
Yeah. So this vector runtime safety, I think it's interesting because it works this way. Let's say that you have a game and you want to make a debug build of your game because there's some wrong logic somewhere that you want to debug. But you also have some piece of code that it's like doing some, I don't know what's it called, rasterization. So like it's just basically taking some data structures in memory and turning them into pixels. And so the thing is doing a lot of work. And also, you don't expect the bug to be there. You know that part of the code is working fine. So if you do a debug build of everything, then maybe that code will become super slow because it will have to do a bunch of safety checks, like not accessing outside of bounds of arrays, integer overflows, that kind of stuff. So one thing that you can do is say you make a debug build of your game, but inside of the function. Inside of the rasterization function, whatever the thing is called, like your drawing function, in there you do set runtime safety false. So in that function, there will be no runtime safety checks. So you don't pay the price for those things, while at the same time you keep them for the other parts of your program. So if you have if you have like something wrong in your game logic, like an integer overflow, that one will properly panic. And so you better like a more debuggable build a debug build of your game that is easier to debug, easier to use, because the critical, like the hot path, is not going to be slowed down by safety checks.
Okay, that's interesting. In Rust, there would be probably the equivalent of enabling debug symbols in release mode to be able to do things like that, right?
Keep in mind though that the interesting thing here is that this works in a scope level. So you can do this. I said that you can do that in your drawing function. So you make a debug build of your entire game, but you never turn on safety checks in your drawing function. Or you can even do so in specific subsets, even within that function, if you want.
So you have a very granular control over what you're kind of optimizing.
Exactly.
Amlug says the implicit TCO works fine. That's just the thing LLVM will do. No work needed on our side. Call modify always tail force it okay, works okay as far as I know. The implementation is a tiny bit janky, I'll have to check. But as long as you're not writing stupid code, it should work fine. As long as you're not writing stupid code, it should work fine. Are you new to the internet? Okay, you can't say as long as you're not writing stupid code. I mean, we're all programmers. That's what we do, right? Have you seen Windows 95? No. Okay, so that's pretty interesting. That's sort of taking the other. There's a lot of granularity with Zig, so it's kind of painting an interesting picture. You're given a lot of levers and buttons to push and set up that allows you to do this in sort of the other direction. Like you said, you would do this specifically for your draw call, whereas in Rust we would say, no, build everything as fast as you can, but enable the bug symbols, right? Now you can obviously do certain things for granularity, but it seems to be a lot more prevalent in, is that the right word?
Yeah.
It seems to be a lot more present, at least in Zig. There is a lot more granular control.
I think this is also useful for actual releases. Like, let's say that you're making a web server, and so let's imagine a future where Zig is more mature. You're making a web server. It might not be a bad idea to make your web server keep safety checks, so that the one time you make a mistake in some handler and you have a buffer overflow, like you try to access something out of bounds, you get a panic. I would say that is a desirable property for a web server. But at the same time, your web server will do a bunch of work like parsing HTTP, parsing JSON, and it's reasonable to assume that the JSON parser in the standard library is solid, will not need safety checks because it will have been tested enough. So what you can do is turn off runtime safety for those parsing code paths. Like literally, you turn it, you open a block, you toggle off runtime safety, parse some JSON, and then toggle it back on. And so that way you basically can have a reasonable mixture of safety, but also avoiding useless safety that hinders performance. Okay, that is pretty interesting. Yeah, so the overall web server is really safe with safety checks on, but then parsers that you trust, you turn off safety for better performance. Okay, that is interesting. So again, it comes down to doing things at a very granular level compared to Rust, right? So you would do you specify the safety checks, whereas on Rust this is a compile time thing. You can't change these, which also has added benefits, like the libraries you use aren't gonna turn things off and do something stupid. Now, no one writes bad code, but sometimes we write accidentally awful and horrible code. So in those situations, it's quite nice to have that. But this is also really fascinating. I can see that doing things like games programming in Zig is probably going to be quite interesting to do. Now, those of you who are watching, who are coming from the Rust cult as opposed to the Zig one, I'm not going to write a game engine in Zig, okay? I'm sorry to disappoint you. There you go, right? Yeah, I think it makes sense to, I'll try to, I don't know, steelman the Rust perspective on this, maybe, as an outsider. You tell me if it makes sense. But I think that also for Rust, the way things work is that you have fewer runtime checks going on in Rust, generally speaking. So maybe most of the time, having something like this would be less useful than in Zig. Like, for example, as far as I remember, by default, integer overflows are allowed and defined to be wrapping in Rust. So you don't have a safety check for that unless you request it, I believe. I don't know if that is... No, that one is something you do specific. You make the choice. You say, I want this add to wrap, or I want this sub to saturate. So if you try to subtract 10 from 0 on an unsigned value, you're going to get 0, right? But you do that explicitly, right? Yeah, no, but I'm talking about the behavior of doing a normal plus. Doing a normal... That happens to overflow. In release mode,
it will most likely wrap around.
Yeah.
I don't know if that is actually defined behavior. I don't know if that's
It
true for
is.
every architecture, but in that
Yeah.
case, yeah, it will just wrap
As far
around.
as I know, Rust defines by default defines overflow as wrapping, so it will guarantee that this is the behavior that you get.
You can
Yeah.
disable that. You have a flag to say,
Yeah.
okay, I want you to break if you do this in release mode,
Yeah.
but that is not the default flag now. Okay, so if we walk back the story, we have quite a lot on the stack now to talk about. So if we start backing up a
how
little
did
bit,
we end up there?
we're
Here, right?
first of all, you haven't told Brian about TCO yet, but that's okay.
Oh yeah,
Are you good, Brian?
Well, I can quickly describe the idea. So TCO, it works like this. Let's say you have a recursive function, right? Let's do recursive Fibonacci. Watch me not remember how Fibonacci works. So you give it a
watch
number.
an Italian person not spell
Yeah.
Fibonacci, right? I'm kidding.
So how does it work? So you switch on n. For 0, you return. I don't remember. Do we start from 0 or do we start from 1?
With 0 and 1 return 0, I think.
No, wait, for 0 and 1 return 0. Wait, was it not like 1 and 1 or something? 0 and 1? Oh, 0 like this?
No. I think 0 and 1 returns 0. Everything else is you know what? Now I'm getting unsure. I think that
Yeah, no, it's 1 1. Okay. I think some version of these have 0 mapped to 1 already. But in any case, let's do it like this. Okay. And then we have else, right? And else is going to be every other number. And so we return n plus Fibonacci of n minus 1. Does that make sense? Is this correct? And then, sorry, we're missing one important thing. Return. By the way, in Zig, you can do it like this if you want. If your switch branches, not at all. This is factorial. Oh God, how's Fibonacci? I don't remember. Oh, Fibonacci.
Okay, fib minus 1 plus fib minus 2. Okay, there we go. Skylar has it.
Holy shit. This is evil. Okay, minus 2 and minus 1. Well, okay, so.
Okay, MLUG says we can't TCO fib.
Oh, right, because, okay, you know what? It's not Fibonacci. Okay, so you know what? Let's rename Fibonacci to fact.
There you go.
Okay.
Oh, that is not how I spell the fact. No, I'm kidding. All right.
N. Okay, whatever this thing is. Okay, let's put it this way. It's N. So the idea is this. Normally, when you have a recursive function, every time you call the function, let me whip out my drawing application. Every time you call the function, it works like this, right? N star. Yes, N star. Critical, important thing. Whatever your function does. The way it works is that you have your stack. And the way it works is that it's going to be called with, what does this thing do? It peels one value at a time, right? So if you give it 5, you start with 5, then it calls 4, then it calls itself with 3, 2, 1, blah, blah, blah. So you have f of 5 that then has to call f of 4, that then has to call f for 3, etc., 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 etc. And so if n is big enough, you're going to immediately stack overflow. But in reality, this recursive function doesn't really need these stacks. It doesn't need all these function frames. You could basically transform this basically into a for loop that only has one accumulator in it.
We're not doing fib. Okay, for fact. 0 is 1. Okay.
There is 1 for fact, yes. Because otherwise everything gets absorbed. There you go. So I don't think we even need the 1 case at this point. So this version can be rewritten as just a while loop, right? You have like your var accumulator that starts at what? 0? Sorry, I don't want to rewrite this. too much brain power. I don't have it right now, and I don't want to fight with chat to get it right. But you get the idea, right? This could be rewriting as a normal for loop. This is not true of all recursive functions. Some recursive functions will require you to basically keep around a growing list of things as you proceed. But for simple ones, you just need an accumulator and you're good to go. And so that's what TCO does. Basically, TCO takes recursive definitions of things, realizes that given the structure, it doesn't need to keep a growing list of things in memory. It can just pull off this with a for loop and an accumulator. And so it rewrites your function that way. So this way you can express something in a recursive fashion and you can give it like pretty big inputs, but then it will not really allocate a bunch of frames on the stack, eventually causing a stack overflow. And so that's what TCO does.
For doing manual TCO, anything that anything that doesn't have any branches or like branching function calls, maybe. And so they have. Okay, can you give us an example?
No. I don't know what they're talking about. What are you smoking? I don't think that's true. Wait a second. We're having a computer science moment. I don't think that's true at all. I think every recursive function can be turned into a for loop, but the for loop will potentially need an array list or like a stack data structure to grow. Not primitive recursive. Give me a link. Give me a link of what you're talking about. I think in general, I think that functions that you write as a programmer that are recursive can all, that's what the function is, right? It's a for loop that basically keeps calling the same machine code in a loop and then keeps passing a different stack pointer at the end of the day. So that's what they are. In any case, sorry, let's go back to the main topic, Toggle.
Yeah, but the general consensus is that any recursive function can be rewritten into a loop. That is absolutely true, with possibility the advantage of a stack, right?
That's how I know it. Yes, that's how I know it.
Yeah. And this is something that you do in Rust, for instance. If you're gonna have heavily recursive functions, then you just rewrite these functions to be loops instead, because Rust does not have TCO any. But so like was mentioned above, if LLVM can make this thing TCO, then that's fine. But you don't have that native in the language like you would in a functional programming language, for instance. Probably all of them have that, right? So in that case, you can rewrite those into. But the complexity of the loop, you can't necessarily just take a function and then just wrap a loop around it and call that function with an accumulator, because you might have functions that depends on the return value of the previous function, and that's when you need a stack, which ironically usually is allocated on the heap in those cases. But that's an aside, right? So yeah, okay, well, so that was TCO. What is the next item on the stack that we're gonna go back to? Was it we're back to the next step. So we did.
The next step.
So we're talking about interfaces.
Yeah,
right?
okay. We were looking at monomorphization. Let's keep monomorphization for now. Okay, so we were looking at this. Okay, what could a next step be? Everybody wants to go.
Everyone wants V tables, right?
Everybody wants to go V tables, but I want to get there with do ease. So let's not get there yet. What could we do? We could do maybe C stuff, just function pointer.
But aren't we making kind of a V table if we start adding function pointers to well, maybe not. Yeah, hang on. Yes, if you add function pointers to a list, you need to get to the data as well. So you kind of build a V table in that case, don't you? Any types as BSS, that is something that, well, we do have any in Rust, but incidentally, that is a trait. What is an any type in Zig?
An any type in Zig is basically generics. We're still in monomorphization land. It's basically a com time argument that can be of any type, and then depending on when the same function gets called, let's say 2 times with 2 different types, then that creates 2 concrete instantiations of the function. So it's roughly what we were already doing with the inline for loop. So let's do function pointers, but with a twist.
Andrew's saying that vtable is doubling direction, function pointer is one in direction. But don't you also need the data for the function pointers?
Yes.
These are not associated function, or these aren't functions. These are methods.
Yes, but you can be clever about it.
That's okay. Even if that's not the next step, I want to see that. Add that to the list.
That one, you basically can get clever with that stuff. So let me do this. I need a quick bathroom break because I've been drinking a ton of tea, and I also want some more tea. So give me like 1 minute, and then I'll show you.
How do you wait? How do you brew tea in 1 minute?
No, I'm gonna put it in the microwave. And then I microwave my water.
Christoph will never be let back into the UK after that one.
I microwave my tea.
It's this American tea now. All right, go make your tea, and then when you come back, I'm gonna go and make teas. If you have any viewers when you come back, that's pretty good. I'm gonna leave the stream in my hands for now.
Okay, so everybody be nice to Toggle. I'll be right back.
All right, you guys are lucky he didn't make me a moderator before it took off, right? A kettle is cheaper to run. Well, yes, you could warm your water in the microwave if you wanted to, but I don't know, man. As long as you microwave the water before putting the tea bag in, yes. So you can microwave the water. It's not entirely safe to microwave liquids really hot in water. They can somewhat react when you disturb the surface, right? If it's like cheating, I mean, I don't think it's cheating as much as it's sort of just unorthodox. It's unbecoming, okay? It's unbecoming to stick your fine porcelain into the microwave, right? You brew tea via friction. I feel like there's a lot of jokes in there, but none of them are suitable for doing on stream, right? How are you guys doing so far? This is pretty good. I'm having a good time. We chatted a little bit before what we're gonna stream about, and I said we don't have to have like an agenda or any real goal. Instead, we're just gonna kind of go with it and see what happens, right? So it's okay as long as you don't forget to put in a spoon. You can't put a spoon in the microwave unless you have like those baby spoons, like plastic spoons, right? You have two interfaces in Zig standard library. The allocator is one with vtable, and writer reader is one with the function pointer. You need one vtable if you more than one function pointer. Tea is made fast by induction. That is also true. My kettle broke the other day, and now I am using an induction hob. And you know what's important? When you have an induction hob, it's kind of important to have. This is what happens when Christoph walks away and it's like programming. I don't think so. Induction hobs, right? Induction hobs, it's important to have a good good pots and pans with those. If you buy like really cheap but works with induction, they might actually be really inefficient to use, right? Well, I guess, so is it just microwaves that are that reactive to metal? And also, the metal have to touch something for it to react, right? How is that? Because there are certain metals you can put in the microwave, but I don't want you to go and try this now because that would be stupid. If you do that, you're awkward, right? Most of the time, you can convert multiple function points to one function. Oh, Andrew is still talking about programming. I think, Andrew, you're lost, okay? This is not the stream for programming. We're talking about making tea now, right? Tin sheets with pointy end, like aluminum foil. Sharp points in the microwave can create plasma. They can, and microwaves are like really short waves. So the shorter the waves, the more bad for you they are. Is that about right? Which means like radio waves in general aren't a concern, and also the shorter the waves are, because of the inverse square law, the less dangerous they become. When you're like, which is why it's okay to be near a 5G tower, but to climb up one and jam your face into it is a really dumb idea. And you can have a microwave, but you don't put your hand in it, kind of thing, right? Don't turn it on while you're inside. There you go, right? Peas can line up like Christmas tree in a microwave. The bigger question is, why the are you putting peas in the microwave? Okay, There we go. Christoph, you're back. We covered putting peas in the microwave, and it's gross. I'm going to go make some tea. Enjoy where the chat is at this moment. I feel like I threw you under the bus. I'll be right back.
Let's see. Was anybody complaining about tea in the microwave? Just so we're clear, I also put the tea bag in microwave, not just water. Basically, the tea comes out of there that's ready to go. Pea in the microwave. Why? Not peas. Peas in the microwave? Like to warm them up? Does that work? Do they explode? They make popcorn? What? Isn't that for British like putting pineapple on pizza? So, okay. Let me tell you the full truth about pineapple on pizza, okay? I said this already in the past for people who are regulars to my stream, but for people who are not, let me tell you the full truth about pineapple on pizza, okay? So, first of all, I guess there are two concepts here that need to be kept in mind. One is you should be free to put whatever the heck you want on your pizza, and nobody should be has the right to judge you. Point number two, though, which is a counterbalance to that, is that if you go to a Italian pizza restaurant where they have precise opinions on how the pizza should be made, and like they have designed a few different kinds of pizzas, and where they spent a lot of effort trying to figure out good combinations, and then you ask them a fucking pineapple pizza, if they don't want to do it, I think that's reasonable too, because when you go to a restaurant, you're not... I understand that this is maybe a different perspective than especially what people think of food in North America, where, you know, the customer is always right. The customer wants to ask the weirdest, dumb shit ever, and they're going to make it to them, for them, fine. But in Italy, that's not how it is. The idea is, generally speaking, that you go there to appreciate not also the perspective of the people who put effort into designing the food that you're going to eat. So going to a restaurant and I would say that if somebody refuses to give you pineapple pizza, it's entirely in the right, and it's totally fine. So that said, let's talk about pineapple on pizza itself. So keeping those two things in mind, like don't go to Naples to ask a fucking pineapple pizza. It's not gonna be good, because people here don't eat pineapple on pizza. They don't like it. There is no culture around it. And so even if the most positive possible interpretation of pineapple on pizza, hello Toggle, you're not gonna get a good pineapple on pizza in Naples, and so you're gonna waste your opportunity to get a much better pizza. That said, put whatever the heck you want on your pizza when you're on your own. If you go to a place where they're genius at putting pineapple on pizza, they know what spices go well with that, they know what spices don't go well with that, go have the specialty pineapple on pizza, whatever you want. Last thing I'll say on the subject is pineapple on pizza is, I get it, it's sweet and sour. It's kind of interesting, fine. But if you want more interesting sweet and sour stuff, which in my opinion is miles ahead of pineapple on pizza, if you never tried prosciutto plus melon cantaloupe, so orange melon, that thing is fucking amazing. That thing is orders of magnitude better than pineapple on pizza. Second sweet and sour combination that is genius is Parmesan and pears.
Oh, Parmigiano and pears. Did you know that in Europe you can call it Parmigiano, but in the US they have to call it Parmigiano Reggiano if it's the real thing.
Yeah,
but you didn't have to do that in Europe.
Yeah, Parmesan is gonna be the fake one. So this is it. So grana and pears. This is genius. For me, it's cantaloupe and prosciutto beats this. Have you ever had it, Toggle?
I have had jamón con melón in Spain, which I guess is pretty much the same.
Yeah, it's the same.
Yeah.
Yeah, this thing.
Yeah, that what you see on the third picture is what I've had the most of, right? That's how I had it served the most.
Yeah. This thing is
it's fantastic, awesome. And it's one of those things that is just absolutely great to sit down and eat when it's on a nice warm day outside. You eat that. Yeah. It's the juicy watermelon is so good. And the saltiness from the ham. Okay, I'm gonna go get my tea. You guys did not disappoint. I come back to pineapple on pizza. I'll be right back.
So yeah, so my recommendation is try this stuff because I think it's like awesome sweet and sour. That is like, and by the way, you can get this stuff in Italy. All these things are very common. It has to cantaloupe has to be in season, obviously. Otherwise, either you're not going to be able to get it or you're not going to get an extremely good one. But yeah, both these things are very interesting. And then I don't know. And then maybe you won't like them. Maybe you will still like pineapple on pizza more. And so go for it. Have fun. Enjoy your pineapple on pizza. Just don't expect to go to Naples and be respected if you ask for that. Be aware. And I'm going to hit Toggle with the Grana Padano versus Parmigiano Reggiano controversy.
All right, there we go. Let me catch up with chat. There is a protected name for Parmigiano Reggiano. Yes, and that is, but if you say Parmigiano in Europe, it's always going to be the authentic stuff. But in America, you can say Parmigiano, but it might not be the authentic stuff. You have to say Parmigiano Reggiano, or rather, it has to be from Reggiano to be called Parmigiano Reggiano. Yeah, otherwise,
there's like a DOP stamp on it that hopefully wasn't faked. You probably might get also cheese with that thing faked as well.
Probably. I mean, it's very, very expensive outside of Italy. It's the same thing with champagne. It has to come from the Champagne region. Otherwise, it's Prosecco in Italy, it's Cava in Spain, and we just call it, I don't know what it's called here. So there's a lot of these things. The same thing with like bourbon and brandy and all these things, right? Mm-hmm. Balsamic vinegar. Okay, so where are we at in the chat then, right? With the Subduck wants to program Go. Okay.
What? Who?
No, I'm
repeat the nickname.
I'm just reading words here. Oh, you guys don't see my screen? For some reason, I thought that
I can turn it on. Sorry, but
Oh no, I don't have anything on here. I should have written something down here for a while. It's the other screen that I have open. I normally have like my chat. And there we go. My wife cuts pasta. Is it legal? As long as you're not in the pasta, I think you're fine. But yeah, pears and cheese though, that does look pretty boss, I have to say. Okay, so how many steps away from function pointers are we? You said there's a trick we don't have to do v tables, but do we have something to do before that?
Yeah, maybe? No, we can do function pointers now. So I haven't done this in a bit, so I might not be able to do it first try. But I'm sure people in chat will berate me as I walk my way towards a working solution.
They have never. Chat is the most forgiving entity on the interwebs, right? They have never.
I don't know. I think that Amlag enjoys watching the stream and like pointing out every time there's something wrong. I mean, he's not wrong. Like I guess the idea is to give people good information, not bad ones. So, but okay, let me think how I want to do it because I was also kind of curious to show you also what people do in the C world. So let's start with the C approach to this. So okay, you mentioned if we want to do function pointers, there's a problem, right? Because the function also needs a...
The object itself, right?
Yeah, it needs the object itself. And so that kind of means, well, then you need at least 2 pointers. But here's one trick that we can do. Let's start by doing this. Speakers is not going to be an array of these things anymore. Let's redo everything. Let's do that now. Const speakers is going to be an array of pointers to speaker. Const pointers, because we don't care about mutating right now, so it's just simpler this way. Sorry, not speaker. Const pointer to, yeah. Now we have the problem. Because these are different types. There's dog and there's person, so we need to do type erasure. So we can put these things, so I'm going to do pointer to any opaque. And then here we put pointer to toggle and a pointer to Loris.
So any opaque is an actual keyword or a type, or?
Yes, any opaque is a keyword, and it's for type erasure. So the reason why we can put pointers to different things inside an array is because they're all pointers, right? They're all the same size. They're all 8 bytes each.
If you put a slice in there, you would get into trouble, would you? You could put a pointer to a slice, yeah, but you couldn't put a slice itself.
No,
in there,
because
right?
It has a different size. Yes. I guess if everything were to be a slice, then I could put a bunch of slices in there. Yes. But
okay, so as long as does any opaque check for pointer size then, or pointer?
No, it's like it's different types. Like if I try to put a slice, it will just tell me that that's a different type. Like
okay, so a pointer is a pointer, and a fat pointer is a fat pointer.
Yeah, exactly.
There's no.
Yeah,
okay,
we
so
colloquially refer to them as pointers, but they are not the same thing. And actually, to be clear, when you have a slice, let's say the speakers exists again, and I do speakers 0 ... So this syntax gives me a slice. When I do this, if I want to access the base pointer, I do .ptr. So .ptr gives me the base pointer. So it's how can I say, a slice also explicitly gives you access to the underlying pointer. So like, yes, we colloquially refer to them all as pointers, but yeah, in any case. So any opaque is type erasure. It means that we are fine data-wise because these pointers have all the same size, but we are throwing away type information. So we don't know what these pointers are anymore.
We just know that they are pointers, right? So we're going to end up... Okay, yep.
Yes. Okay, so now we have the problem then. What do we do? What do we do with these things? Because it's any opaque, so we lost type information. We don't know about their structure anymore. If these things were extern structs, we could know a little bit more, because we could say, well, we know that the first item in here is a slice, so we could access it. Let's try this. Let's make it happen. So first of all, I need to put extern in here. Actually, let me show you what happens if I don't, so that you can see this happen. So here's my goal. Okay, right now we're working our way towards a solution, but as a stepping stone, we're trying to do this. So these types, we know that they have name as the first field. This is not enforced. We could by mistake put in there something that doesn't start with a name, starts with something else. But for now, let's assume that we're gonna respect this invariant. We're gonna guarantee it. So here's what I can do. I can take this any opaque pointer and I can cast it. So I can say name is gonna be it's a slice. Actually, it's a pointer to a slice. It's a constant pointer to a slice because the slice can't be mutated.
Couldn't you just dereference it, or is that?
Yeah, I could dereference it. Like I could on the other side also dereference it. That would also work. You know what? Let's do it.
Save me from having the const in there.
But let me think. Actually, I'm not sure. I think there might be some other type system annoyances if I were to do this. So let's not do it. Let's not do it for a moment. But the end result is the same. So I'm gonna take this pointer. I'm gonna do pointer cast. Whoops. And I'm gonna pointer cast s to name, and I'm gonna try to print name. So we're gonna do the thing where we print the name for now. Forgot align cast. Oh, I forgot a lot of things. Name. Okay, let's try to make it happen. Let's see. So pointer cast increases pointer alignment. So an NUPIC doesn't have any specific alignment dedicated to an NUPIC defaults to an alignment of 1, which is basically it doesn't have any alignment requirement. So what we can do is align cast, or we could say that we're fine with receiving a slice that is potentially misaligned. Or here we say that the type is going to be a pointer to an NUPIC, but with a given alignment. I think you put it in here. Oh, it goes before the const. Okay.
Wow. Okay. Yeah.
So
me.
We could do it this way. Let's see what happens if I do this. Okay. This way. Okay, so I have some. I'm dumb.
Slightly different memory addresses, right? So there will be that makes sense, right?
Yeah, that makes sense. And also, I'm silly because this is a pointer to this thing, and so to actually print name, I need to dereference it.
Hey.
I'm actually surprised that this works. I was expecting to get a compile error. Because these are Zig structs, so they don't guarantee the name is actually the first field for real. And I think I run it in release mode. Okay. Still works. I mean, this struct doesn't have anything else in it. This one has a single byte item, which obviously wants to go after. You want to put it afterwards, not before. So,
can I ask a quick question about the alignment, though? Where was the alignment written? Did you include? So you say align this by 8 bytes. So does that mean that you're gonna jump 8 bytes to the next pointer, or that every pointer points to something with 8-byte alignment? What is the alignment?
It means that every pointer, when looked at it as a numeric value, modulo 8 equals 0. In the way,
okay.
But that is implicitly true. Like typed pointers to Loris and dog, and toggle, or more precisely, pointers to person and dog will always have the correct alignment, because naturally these things align themselves correctly without you being explicit. But since we're throwing away type info, this is basically us retaining a little bit of the original type info. You're retaining the alignment information. So yes, what happens if you put align 16? If I put align 16, potentially there's going to be trouble. Let's do it. Yeah, it says, well, yes, you want to create an array of these guys, but person can't be coerced to this, because person, it doesn't say it here in the type system. Oh no, it does say that as a note. It says, well, the pointer alignment of toggle is 8, and you're trying to turn it into an alignment of 16, and that cannot be done.
This is a compile time error, right?
Yeah, this is a compile error, because the type information of these structs, given what they have inside of them, makes them have an alignment of 8.
Can I infer the alignment? Can you underscore the value there? Here? I think the most obvious for non-SIG programmers, they probably wonder, why do you have to put the alignment in the first place if you can't? If you can't put the wrong alignment, why do you have to put it in the first place?
Well, it's a type information thing. If I don't put this, then I could have something else that has alignment 1. It could be like const snake, and snake contains just, I don't know, a U8. And so this struct doesn't have natural alignment 8. It doesn't need that, because it doesn't contain any pointer, it doesn't contain any U size, it only contains a single byte. So the alignment, the natural alignment of this struct is going to be 1. And so if I try to put a snake in here, I need a snake. This is a type, so const mlag. So if I put, so this will work because this guy has alignment 1, but it's fine. They have different alignments, but the way I've defined this type for this array is one where we don't care about the alignment.
It's a way to get you back here, Emlug. We need you. Okay, don't go anywhere.
So
marinated chicken doesn't take that long. Okay, so can we still iterate over these even if we don't have an alignment?
Let me remove the snake part.
Okay, so we have to have the same alignment for everything, even if we use the any opaque.
Not necessarily. We don't have to do that. We don't need the alignment for the type, but they are going to be right now. We do care for this stuff to work. We care about the types being homogeneous, and so right now we're using name to make them homogeneous, and so they will need to have the correct alignment. So I'm going to put it here. An alternative could be, as I said, that we could not put this here, be fine with types that have different alignment. And then in here, we also do an align cast. It also
and
works.
Then would align cast work without specifying the alignment then?
Yes, because it would assert that these pointers have the same alignment that this thing expects, which is 8. And so if I were to put snake in here, if I were to put back mlug in here, which had alignment 1, then the align cast would panic. In any case, like we're getting a little bit deep into these alignment stuff. It's right now it's not so
okay. I want to come back to it because I find it interesting. Everything that I think of when I see these things is coming from I'm obviously a very seasoned SIG developer, but a lot of my community are not. And those of you who are here, you might have these questions that I seem to be asking a lot of, right? No, but that's kind of what it comes down to. So when you can do things in 2 different ways, when you're not familiar with the language, you kind of want to know which is the way I should be doing things and in what circumstance should I be doing this thing, right? But we can come back to that. Don't let me detract you. Let's pop on the line 8.
Okay, so align 8. Then here's what we're gonna do next. Okay, so we try to print name and it works. I expected it to not work, but it did work. That I think this is a. You know what? I'm not sure actually if this can be fixed, but I can show you this. Because I wanted to trigger a compiler error. So just so that we're clear, here we're doing something wrong, okay? Because we are assuming we're assuming a well-defined memory layout for these structs, but we didn't make them extern.
Right.
That's the problem, right? So that's the problem. And I was hoping to get a compiler error, but this way we don't get it. I think that we can get it but I know that I triggered it. I remember triggering it in the past. I just don't remember how. So this code path probably in line 4 would error. Let's do inline 4. Ah, there we go. Yes, thank you. Comp time the reference requires consuate to have a well-defined layout. Wait,
and that is because
this is complaining. I think the error message is wrong. Wait, this should not be complaining about the slice. This should be complaining about the original type. This should be complaining. Oh, because it's any opaque though. Oh no, you know what the problem is? Okay, I get it. Zig cannot give me this information because we're starting from an any opaque thing. Like if I were instead to do this from toggle, then it would know. It still complains about this. Why is this not complaining about? I expected this to complain about person not having good memory layout. Okay, it's getting a bit confusing. Let's continue. Let's do the right thing though. Let's let's make this extern so that it's correct. The message is right. The slice and the origin type are both wrong. It's just picking the slice because both are errors. So it's arbitrary. Yeah, but wait. That still doesn't tell me why I can't dereference a slice. Why are you not allowing me to dereference a slice? Like, even if the memory layout is not well defined, a slice is still going to be a slice, right? What am I missing here? Let's see. X structs cannot contain types consuate. Oh, well, you know what? I guess we have another problem though. You can't put slices inside of C style structs. That's annoying. Okay, let's go to this then.
Is that because there's no C representation or slice?
That's a good question. What is the reason for preventing Zig types to be inside of X structs? Maybe MLog has a good answer to this. Okay. I do have one, but I will give it in a bit. Okay, so he's still touching the chicken.
That did not come out right.
Okay, so in the meantime, let's do this. I'm gonna turn these slices into C-style strings with where I'm not keeping around the length as a value, but I'm leveraging the fact that they have a null terminator at the end. Okay, so I'm changing this to a normal pointer, and then we're gonna need to actually do nothing. So this is gonna be fine. Let's see if it works. Well, let's see what else I need to do. X and structs cannot contain fields of type dog enum. Oh man. Okay, the enum is also needs to be done C style.
Okay.
Let's see. Enums do not support part or extern. Instead, provide an explicit integer type. Okay. So this is gonna be a
U8.
U8. Yeah. Okay. So
hey, there we go.
Now it works. There will be no chicken touching. Well, you can't stop him though. How do you prevent him from touching the chicken? I don't know.
I think we're too late for that, man. We have to read about
yeah,
this.
You can try to make a law
tomorrow.
about not touching chickens, but then if you can't prevent it from happening, the problem is that you need no chicken enforcement police, and unless you have that, the chicken will be touched.
We were doing so well. It went downhill so fast. Oh man. Oh my goodness.
Okay, so I had to turn my types into C-friendly types. But that's because I all of this, by the way, is that because I wanted to show you, I guess maybe not the C approach to this, but a approach that you can occasionally find in the C world. So we're C-fying the Zig program with all the ugliness that comes with it. Okay, so here's the trick. Then we want to go from this to actually having the proper, runtime polymorphism thing, right? So here's where things get interesting. Here's how it works. We don't put name as the first field. We put instead speakfn, which is going to be a pointer to a function that takes in a pointer to any opaque and a slice, and doesn't return anything. So we're adding a field that is expected to contain a function pointer, and we give it also to person. And for both, for simplicity, let's give them also an init function. Name const U8. So we still use normal Zig types, and then this returns you a person.
Wow. Okay. This is gonna be interesting.
Yeah. So name is going to be what gets passed in. And then we need to fill out speakfn. And we need to change the signature a little bit. So we're going to change the signature to be a function that accepts p as a pointer, not to person, but to any opaque. And internally, well, let's call it context. And then we reobtain a p, a person, by pointer casting. Actually, we can even set the alignment here. This is going to work. Usually you don't put the alignment there. Usually you just do a... I don't think this is correct way.
Well, we'll
Are you
see,
saying that it's not going to work,
Let's go with
Andrew?
it.
We'll see. So here, then we do a pointer to speak.
Wait. Where is speak? Your pointer to speak is referring to speak within
the scope. Yes.
Okay, so you don't have to. Could you call speak in this function without having to prefix it with anything?
Yes. In Zig you don't, because we don't have, like, there cannot be an outer speak. If I try to create an outer speak, then it's gonna complain that it's an ambiguous reference.
And the way, can you get around the ambiguity by prefixing it? This, gotcha. And what about fields? Do they have the same rules, or is this just for functions?
Fields you always access from a self parameter, so they always have to be qualified.
Okay, that makes sense. Otherwise, that name input wouldn't work. Gotcha. The name arg.
Yeah. So, yeah. Okay, let's go do that also down here. So there's going to be an init. This returns you a dog. Sets name. We also need to pass in an item. Oh, this is annoying. We want to put a type here for item, but we are defining this type in line. So it's annoying.
I was wondering about that. Can you use something like, okay, you have to make that. Gotcha.
Yeah. Alternatively, I could have done this. So this is I guess the better way of doing this.
Is this considered either good or bad practice to define the enum like that instead of an anonymous enum? This enum could be defined inside and outside of the external struct, right? As far as I'm guessing.
Yeah,
that's just
inside or outside doesn't matter much. Like sometimes it makes sense. Like if item is, a property specific to dog, it makes sense to namespace it inside. So it's not a bad idea. Inline versus creating a dedicated type is just if you need to refer to it. An alternative way could have been that I left enum where it was in there, like an inline definition, and here I did any type. That would have worked. But then my users would see the signature saying any type, and then we say, like, what do you mean by any type? They would have to look at the code and say, oh, yeah, this guy means this type here, but so it's annoying. So it's better to do this.
Can I refer to this item outside of the dog through the dog type? Can I do dog item somehow?
Yeah.
Dog.item. Yeah. Okay. Now that makes sense. That felt intuitive, like it was going to be like that. Gotcha. Nice.
Okay. So we have item, we have init, we have item, we initialize everything. Now we need to fix dog.
We need to fix dog. This kind of makes sense. I think this is... can you do type of this dot item? that would get you the type of the what is the type of lowercase item, right? So that would be still an anonymous type, right? Can you does that work, Christoph?
I can do something like
understand
this. Not with the syntax, but it can be done. Yeah.
Field type this item. Gotcha.
Yeah. So yes, it can be done. But I would say this is maybe slightly less cursed than putting any type, but it's still freaking lazy in my opinion. And this is freaking superior.
When it comes to, I mean, absolutely being explicit like that definitely makes sense. When it comes to so these are the pointer cast. Are they causing any kind of indirections? Do we have any quote unquote performance implications by doing this?
I think we can get to that in a second.
Okay.
So yeah, keep that in mind. Don't forget about this question. Let's see if we can demo this also. Okay, let's make it working first. So we have this layout. So now what happens is that every time we get a speaker, now when we turn that struct pointer from a struct to its first field, now we need to cast it to a different type, right? This is the type that we need to cast it to. Here's one thing that you can do also. We can do it like this. I'm basically just taking the function signature type and putting it in a shorter name so that we have.
Would that be the same akin to a type alias then?
Yeah, it's just exactly. That's just a type alias. Okay, so speakfn. So this means that now this cast can become a cast to a speakfn, or rather, wait. This is a pointer to toggle, right? So this is all gonna be a pointer to speakfn. Does that make sense? Because here we're not placing, so if we were to place in our array the actual struct, then the first few bytes in the struct would be a function pointer. But since we're putting pointers to our struct, then that's going to be a pointer.
Is it supposed to be name is a speak function pointer?
No, it's not name, sorry. Then there's going to be speak. I'm going to call it speak. And then what we want to do is this. Sorry, yes. We want to do speak.
Okay, right. Yeah. All good.
Kinda. We need to put stuff in there.
S as well,
yeah,
right?
we need to put stuff in there, right? We don't know yet what to put in there. But the idea is to do something like this. Okay. I think, I don't know, if this is a function pointer, I may need to do this because it's not a function itself. It's a pointer to a function. So I think I will need to dereference it one level.
I feel like this came up when I was messing around with things. Oh no, that was in C. Sorry. Someone in C, a function is always a pointer, I think was the general consensus. So I have no idea.
Well,
but
we'll
good on Chewy
for
watching the rise. Get rid of that starch, man. You don't need it. All
okay,
right, so
now the problem. Let's look at the function signature though. We need to pass it a pointer to the struct, right? So that's S, and then hello. So this is the idea. You don't need to deref, and it will break if you do. I don't think so.
Yeah, amlog.
I don't think so because we're grabbing, because these guys are pointers to the struct. So this pointer to the struct need to be dereferenced to get a pointer to the function. Like, keep in mind that speakfn is already a function pointer. Yes, so this is a pointer to a function pointer. Yep. Okay. So setting aside the pointer dereference thing, it's not that complicated. It's just slightly annoying if you're not used to it. But this is the idea, right? We place a pointer to our specific implementation, and that one is going to be different for dog than it's going to be for person. Actually, we kind of unlocked one extra power if you think about it, because right now we have one speak function for all people and one speak function for all dogs. But once you put a field function pointer into every specific instance, yeah, sorry, I don't know. I introduced a bug in Bork. Emotes bug out after a while, and I don't know why. I need to fix it. So as I was saying, the moment that you put a function pointer as a struct field, then you can personalize it per instance. You could give a different function implementation for Loris and a different one for, well, Toggle, although we are different types, but you get the idea. Let's say that we were both were person. Let's imagine a hypothetical world where both I and Toggle are of the same species. We're both people. And so you could give us different implementations as individual instances of the same type. But we're not doing that for now. So we're sticking with one per type. So, okay, let's see if this works. External structs cannot contain fields of type pointer const. Oh, it's complaining about the function pointer being a Zig function. This is so freaking evil. Why is this like this? Okay, we need to take this function and make it a C function, extern function. Man, okay.
And then I'm guessing the type alias needs to be...
sorry, not extern, export.
Well.
Yeah, export. Okay, export or star colon 0. We need to do the translation of all types to C compatible ones again. Actually, did I remove the const? No, I kept the const. Okay, export. Goes after the pub. Stupid way of doing it too. Whatever. Let's see what the next problem. Oh, and this function needs to be a... Okay, you know what? You're right. Let's not do export. It means it at the end of the day, it will imply the same thing, but since we use call conv in the signature, we use it also here. So we're saying this needs to be a C function. Again, we are C-fying our stuff, and that's the price for it. Okay, how far do we get now? I
think you still have an export in there.
Oh, I do?
948.
Okay, I'm going to delete that. Okay, let's see the next problem. All right, we're not calling init functions. So let's turn these static initializations into calls to init. Check this out. This is a new thing that you can do in Zig 0.14.
That's nice. So you kind of know what function or what type you're calling that on based on what is on the left-hand side of the equal sign.
Yeah.
It's always these trade-offs where you quote unquote hiding things, but you're not really. I very much prefer this, and to me, this is a bonus to do it this way. Even if you have long types and things like, even if and again, like you don't really you because you use the dot, you know the brandy comes from the dog as well, right?
Mm-hmm.
Will that work? Will the dog know about dot brandy? Because this now attached to the item, right?
Yeah, it will know because this init function is this init function. Yeah, since we have the type information, we will select the right init.
So because the item there,
because it's
right,
a type of type dog. So what basically defines which init we are looking at is the fact that we know the type.
Yeah, I was more thinking about the dot brandy thing, but you know that it's that enum because of the type of the input.
That has been working in Zig since forever. So you could selecting enum variants with just implicit dot syntax also works since forever. 0.14 has the ability to do that also with functions and decals declared inside a type. Okay.
I like it. It's good.
Okay, so let's go through more compile errors. So discard this pointer cast discards a const qualifier. Good point. Where are we doing here? Here, this is actually a const pointer to speak FN. Let's see what the next problem is. Except the type align 8 any opaque. Found align 8 const any opaque. Yes, I forgot a const qualifier. Let's continue. Expected type this found this. Oh, interesting. Wait a second. Do you not do dot pointer? Can you Can you do the just straight assignment? I think you can, maybe. Let's see. Expected type found constrained. So no, wait a second. Okay, I think I get it. The problem is that here we need to say that these slices will need to be null terminated.
What does that mean, Mlog? You don't have the sentinel on the slice? What does that mean?
Yeah. What I just did. Basically, also for the slice, you have to say that this is a slice of a string that is null terminated at the end.
Okay, so :0 means null terminated.
Yes.
Would :1 mean 1 terminated, or?
Yes, it would mean.
Okay.
It would mean that exactly. You could have like a terminated.
Wow, that's pretty cool, actually. So you could do a new line character for the string termination.
Yeah. Yep, sure. Yep, totally.
That is cool. That is. If languages, at least new languages, have these interesting, quirky bits that makes them. They kind of introduce different way of thinking about things, right? So that's really interesting to have a new line ability to have a new line termination on that.
Yeah. So we're calling the speak function with hello. Let's change this to hi Twitch chat. We run it and it works.
Nice.
Person Togglebit says hi Twitch chat. Dog Lorry says hi Twitch chat. Woof. So this is how C does it sometimes. In Zig, you don't do it this way. You do what Amlag is bitching about, which is field parent pointer.
So poor Amlag's been such a trooper today, but then there was the incident with the chicken, and we just couldn't really move past it.
But no, right. He's right. So in Zig we don't. You saw how we pulled in a ton of C-isms right everywhere. For interoperability with C. I feel like some of these restrictions are maybe a little bit draconian. Some of things maybe we could have gotten away with a more like type system. We could have still done it. But it's a C-ism. So you will feel. So going back to the original goal, right? Runtime polymorphism. Runtime polymorphism can be done if your struct contains a function pointer to its own implementation. That also works. And if the function pointer is part of the struct itself, then that same pointer can also double as the data pointer. It's the pointer that gives you both the function and the data. Does that make sense? This is the trick, right? You have one pointer that doubles as both. That's the key. I guess that's the key trick. The key trick is that you're trading a little bit of space, because now our structs need to hold a function pointer. And so they are a little bit fatter compared to what they were before. But in exchange, you pass around a single function pointer. And well, the fact that they all start with the function pointer allows you to treat them interchangeably. And like, I think that's how a lot of things work. Like, for example, I might be wrong, so don't quote me on this, but I think that in Python, in the C Python interpreter, what is a Python object is a C struct called pyobj, something along those lines. And I think that I don't know if it's a single implementation. There might be multiple implementations, actually multiple structs. In any case, sometimes what happens is that by having a commonly known header, like you know that these structs might be different structs, but you have a pointers to these things. But they always will start with a function pointer to this implementation, a field that is always like an enum that tells you what underlying type it is, blah, blah, blah. So you can start basically inspecting at runtime the struct layout a little bit, and so that you will know how to use it going forward, if that makes sense. So it's not formally a union, but by having a common header, all structs, then you can kind of use them interchangeably.
Okay.
But you can't put them directly in an array. You can only put pointers to them in an array, because then they will have different sizes. Yeah, I think the emoji bug is consistent. Sorry, I think it works at some point and then it just stops showing those messages. Ah, no, it doesn't have to do with that. Not the emoji one. What's the problem with that? A Twitch bug. Oh, you probably have some escape stuff that gets eaten by it.
I see both messages fine on your screen and on my screen. Blah, foo, blah.
Yeah, I think though that he hasn't sent that. He sent something different, and some of it got eaten by Twitch.
But it's the I see. I thought it was a difference of what turned up in bulk and what turned up on Twitch chat.
Bork is truncating a few bytes from the start. Is it? Not really. No, what we see in Twitch chat is also the same that you see in Bork.
Yeah,
so
I have the same thing, mlog, on both my screen and on I would say my
Yuck. What? That's not Bork. Why are people yucking me on YouTube? What?
That was 45 minutes ago, man. So tube incompetence, how you doing? Welcome to the stream. We're a little bit late getting to you, but it's been a busy day. How you doing and what have you been up to?
Maybe this was a comment in reply to the pineapple on pizza thing or the chicken touching. We'll never know.
Oh, the chicken touching, I think we were all on board with that. But with the yuck comment, not
so
the
this
actual
is a chicken touching stream. Okay, so I
think, listen, mlog, don't judge Christoph's stream by what happens here today, okay? I feel like I'm possibly a negative influence here, okay? So you'll be safe for the next stream, okay?
Nice. Temporis, do you have a link? Do you have a link to like a couple struct definitions that we could quickly inspect for this? That would be I think really cool.
Possibly.
You were AFK making bacon. Oh, I thought you were AFK touching a chicken.
Yeah, that was the whole thing. It was just like you gonna something about someone touching a chicken, and the whole thing just went off the rails from there on out. Okay, so what's the So we've covered doing this with function pointers now. Yeah. I have to say I'm a little bit at loss, right? So we're not doing this with a V table. We're doing this with function pointers, and we're saving one pointer in direction in doing so. Is that right?
Yes, you pass around fewer things because a struct pointer basically doubles as everything. Like you just need one struct pointer, and then you get out of it the function pointer and everything else. Let's see. Stream handles. Stream handles provide an abstraction of a duplex communication channel. It's an abstract type. libv provides 3 stream implementations in the form of UV TCP/T, pipe T, and TTYT. Okay. And then what was the other link? TCP/T can be treated as a stream T.
So shared headers.
So can we see like TCP/T as in like in source code? TCP/T is a open quote subclass of stream T. Can we see the definition? Where's like a link to source? Power fields and a. Wait, is this C++? Are we looking at C++ stuff? No. Oh, let me find it for you. Thank you. So basically, you see how this is saying subclass but in quotes. It's because it's using this header trick that we were discussing up until now. And maybe they don't put function pointers in there. Maybe they put something else in there that helps them disambiguate which case it is. But the point that Temporis is making is that, so this library says that they say, let's imagine that you have a stream T type, which doesn't exist for real. It's actually a pointer to either a UV TCP/T struct or a UV pipe T struct or a UV TTY struct. And then these pointers can be used interchangeably with this API because this API knows how to only inspect the common header that all these structs share. And so that's why these APIs can use these types interchangeably. But I'm surprised that this thing doesn't want to link to source code. Like, come on, man. Okay, you know what? Let's wait for Temporus to find the link. Let's maybe make some progress in the meantime. Okay, so what do we want to do next?
What would be the most reasonable thing to do? What would be like the most common thing to do? Would that be a V table, or would this be the most common thing to do?
The most common thing to do at some point in time in Zig used to be basically a more Ziggy version of this with field parent pointer. But I believe that this style has been kinda, well, not fully abandoned, but like has taken a backseat because, as far as I know, as far as I understand, it just so happens that LLVM is not good at optimizing that kind of code. So like LLVM is basically optimized for optimizing C++ isms more than anything else, and so apparently it just can optimize vtables much better than it can optimize these pointer tricks. Okay, let's look at the what Temporus found. Okay, so this is TCPS. So it's a struct. Oh no! Oh, UV handle fields, UV stream fields, TCP private fields. Okay, so they clearly have defined this struct in this way, but I don't know if it's immediately clear to you. This syntax is not like write C syntax. You don't put variables like this inside a struct definition. The reason why this looks like this is because it's a freaking macro.
Yeah, I'd imagine that thing will inject the field values.
Yeah, there we go.
There.
Here's how it is: void star data, UV loop T, UV handle type, UV close. So handle fields. This is basically the common header shared by all up until here, I think. Here.
Well, isn't this all the common fields on all of them? So if you want to add additional fields because of the offsets and the layout, you have to add them after the macros. I don't know if they have any though, but this is everywhere. I can imagine that this would be, so if you want to have your, there you go, TCP private fields, they have to be at the end.
Yes, they have to be at the end.
Anything that we, empty, okay.
Yeah.
So everything, there was the TCP one, then there's the pipe, and I reckon the pipe looks exactly the same, except it has private pipe feeds as well.
Yes, it has pipe function F name. I don't know what F stands for. Maybe function, maybe not. I don't know, but it does have that. Yes.
Yeah. Well, okay. I mean, if it works, it works. I have to say that Rust and subsequently Zig as well has made me more interested in C than not. I had no interest in C before I started the programming with Rust and tinkering with Zig as well, right? C is kind of interesting, even though it's not really that fun, because the language features are good for a reason, right? I mean, there's a reason why you have the dot syntax as inferred in Zig, because no one wants to type out all that stuff, and we don't want these kludgy things that is solve everything with a macro. You can do what you can do, everything else is solve with a macro, right? Yeah. There's a reason these things, because they're painful to read. Rust has an awkward macro system. You have two types of macros. You have declarative and procedural macros. One of them operates on the token stream of the language. The other one is sort of a weird sub-language of Rust. And in Zig, you don't have macros at all, I take it.
Yeah, no macros. So, yeah, I guess there are like two aspects in here that are kind of intertwined, but that are fundamentally different things. One is, let's say, let's call them maybe memory tricks, like tricks that you can employ to get behavior from your program. So saying, you know what, I will put a common header in a bunch of different structs, and that way I can use them interchangeably a little bit to some degree. Then that's a technique that you can use to get some behavior out of your programs. And then, unfortunately, that intertwines then with horrible limitations that C has in terms of metaprogramming. And so the two things, even though they are fundamentally different, in my opinion, they end up intertwining, and then they create this weird system where it's not clear if it's a good idea or not. It's like it's a mixed bag, in my opinion, because you end up with having, yes, these struct being defined with a bunch of macros, which is probably a good idea, because if you don't do that, then what you risk is that the header gets, somebody doesn't know about the system, and then they add a field in the wrong place, everything goes out of whack, and it's not immediately obvious how to define
the alignment is now wrong, or the field layout is now wrong. So these things are, they're a bit insane, because they can get hidden very deep, and they're all operating under the please don't change this rule, which is hard to enforce, right? So no, absolutely. Okay, so we did so do we need all these extern in our our code now?
No, we don't. Okay, let's do the more Ziggy version. This is the one that I haven't done in a long time, so I might be misremembering stuff. Here's what I'm gonna do. I'm gonna undo all the Ciification.
Have you checked if Helix has an earlier command?
It does.
It does. Beauty.
I'll still go step by step, though.
No, Mlog, there's just chicken. We're all in favor of tea here.
Let's start about touching tea. No, you can touch tea. It's fine. I mean, you can touch chicken. I mean, we decided that touching chicken is fine.
Yeah,
so
we don't judge you, man. You touch that as long as it's consensual, man. We don't judge. It's all good.
So after that, we're good.
It's all you in Helix.
All to you.
You used to patch. Why did you stop, Skylar? Why did you stop until the chicken? How long were you patting this chicken for, and how hard? Because I feel like that's I don't know, man. Until the chicken says, I have been petting this chicken for 12 years now. Okay, so let's do Zigification of function pointer.
Yeah, we need all this stuff. The basic trick is still the same, right? The basic trick is we want these types to all somehow give us a common thing that we can use as an interface. So the way it works, I believe, okay, my memory is fuzzy because I haven't done this in a while. So we need to add a new field to our structs. That's for sure. Let's call it speaker. And then speaker will have to be a struct that is embedded within this other struct, and this struct has speakfn. Okay, let me double check this for a second.
Mm-hmm.
So we need to put in there pub function speakfn.
I did that the other day, Mlog, and then I set the timer and waited for the tea to brew, but I forgot to put a tea bag in there, so I just put a cup of cold water on the table and waited 3 minutes. Needless to say, it wasn't very good. Cold brewing, they call it. Oh, and then you need the tea bag, though, don't see us. Welcome to the stream. How you doing? This is really good, by the way. I think doing like 2 people streams is good. Fundamentally, the best way of streaming for the only reason that you can kind of go and make tea whenever you want to, and there's another person that kind of runs the stream while that's happening, so you don't need the AFK screen or anything like that,
right?
Thank you, Beat Watcher.
Okay, I have it. Okay, so we'll need to create a different version of speaker. Const speaker is gonna be this. Let's disable our previous idea of what a speaker is supposed to be. So now speaker is a struct that contains speaker function. Okay, one sec. Then we put a speaker, and then we're gonna need. No, I don't have it. Man, I almost had it. Okay. Give me a sec.
I will
We're gonna have a
talk
mini
in
function.
the meantime.
Yeah. Please chat with people.
All right, Beatwatcher. Wusa likes this. Maybe instructive is better. Is this a better English word than informative? I don't know. I mean, both are pretty good words, and they start with the letter I, so that's pretty good. I don't know if this is the table, Skylar. Any pointers for getting into streaming? I might want to stream some Sig at some point. Yes. Tell me. You know what? First of all, change the name to something that I can pronounce. That's your first job. All right. Secondly, what's the purpose of streaming? Right? Do you want to stream because you want to be an influencer like Christoph, or do you want to stream because you want to just share the work you do? What's like important to you? Is it to grow an audience, or to just have a small community kind of thing? Because this matters a lot with how and what you stream, right? It's just some easy German. Der Teufel Twitch. There we go, right? We should be able to do the Sig interface version in C. Teufel. Der Teufel. Teufel. All right, for the remaining 2 hours, I will be pronouncing Teufel. I want to stream to become not ashamed of what I program. You know what, Don? The first thing you got to do is then resolve the thing that you are ashamed of, right? So you stop being ashamed of it, and then you just stream. Just to postfix Twitch. So it should be like .der Teufel, right? I have postfix for different platforms. There you go. We're doing like it's almost like the Hungarian naming occasion, but so it should have been Twitch and then uppercase D, right?
Okay, I think I'm not doing this right. I think I'm missing something. Why this is missing field parent pointer? It needs field parent pointer to work. Why am I doing this wrong? Right. Okay. Pub function speak.
We have interfaces at whole moment. All languages have the shortcomings. But I like it.
Okay, I get it. Oh, yeah. Okay. I'm getting there. I'm slowly getting there, but I am getting there.
Keep going.
So slowly getting there, but I am definitely getting there.
You gotta gonna have to explain all this to me starting from the top once you get there as well.
Yeah.
Because I'm reading chat as well, and chat is a little bit too far away for me to follow everything that you're writing. If you want to stream so you can focus nicely on stuff I want to work on in Zig and add something to the community that I like, that's a good point. I know, Priva, nobody knows. That's a good point, Teufel. And it's a very valid reason to stream. As a matter of fact, if you find yourself trying to do work on something and you get distracted by other things, when you stream, you cannot really be distracted by the same thing, be it something like watching YouTube's public masturbation, whatever it is, right? You cannot be distracted by this stuff if you're streaming, hopefully. So for that reason, I would say it's pretty good to stream. The only thing you really need to do is make it a habit to talk about what you're doing. And for some people, this really helps when you talk out loud what it is you're doing while you're doing it. But some people, it becomes distracting, right? So you can literally practice. You're gonna feel stupid doing this, but you can practice this alone in your room, do something, and just narrate what you're doing. Maybe not like narrate, be like, I woke up and I felt incredibly strange this morning. Turned out I was a hamster. Like, don't do that, but so like, okay, this is why we do this, this is why we do that. Kind of what Christoph is about to do now, because I don't understand what's happened there, right? If you want help with streaming setup, you can ask me or Chris, man. I was going to say Christos as your operating system. Ask me or Christoph if you're on either our Discords, if you want to get into streaming. I'm sure Christoph is equally happy to share. As a matter of fact, Christoph has helped me with my sound setup. So if you enjoy these crispy notes, actually not through this program, that's going through OBS. Anyway, I digress. I know, even put in an earpiece, which I can talk and give him hints. Why don't you do a stream someday, Logo? Right? Just take my place one day. And leave the chicken out of it, though. But take my place, and then you can just sort of.
We're gonna need to have like 3 webcams: one for him, one for me, one for the chicken in the middle. And then at some point, we're still gonna have webcams that like the webcam shot is gonna be over the shoulders, right? So shoulders are not showing, and then at some point you see a hand in a chicken webcam touching the chicken, and you have to guess which of us it is.
You see a finger come towards the chicken.
Yeah, you see a finger, and then the game is that we need to look serious, right? So you need to touch the chicken maybe as you're speaking, right? Maybe you're gesturing so that people think that you're definitely not thinking of touching the chicken, but in the meantime, like a finger starts touching the chicken.
I feel like we're gonna have to change the stream title soon, but okay. Do you feel like you're ready to explain this one now?
I think I'm ready. It's not fully done yet, but I think I figured out the missing pieces, and now I can explain it and like complete it together so that in a way that makes sense.
Okay, let's go. Cohesion.
Okay, the basic principle is still gonna be the same. The basic principle is still you have a pointer to something. And that pointer, so first of all, 2 things. One is the struct itself needs somehow, somewhere to have a pointer to the specific function. And then we need a way of homogenizing access to a struct. So what previously was a common header, right? We assumed that all structs started with the same stuff. Now we're not going to do the same. Now we're fine with, we're fine with basically placing the common stuff somewhere else in the with something else in the what's it called in the struct itself. So here's how we do it. Let's see. I need an earpiece because your arg should be now .speaker, not .anyOpaque. You mean here? So here it's correct. Yes, of course. We'll get to that. We'll get to that in a moment. Okay, that's part of this function I need to fix. Yes, I still need to implement it. So here's the idea. We create speaker as a dedicated type, as a dedicated struct, and speaker will contain the function pointer. And then it basically, this is what offers the, uniform interface. So at this point, we don't need anymore every specific implementation to share the same speak name. Well, we didn't need, I guess, that before either. But just to make it clear, now the polymorphic function also speakfn needs to pass s as an argument. Yeah. We'll get to that. Well, wait, isn't it doing that? No, it's not. Yeah, right. Okay. So,
do you have to pass it if it takes self as a? I thought that was sort of magical. If it takes the same type as you pass in. I don't know if that comment made any sense.
So this needs to be, maybe you're right. Wait a second. So if this is a const speaker, actually, I don't know. No, I think I don't. I think this way works, right? I think this, actually, no, because it's not a function declaration. Yes. Since it's a function pointer in there, no, we need to explicitly pass it in. It's not in normal function decl, so yeah, it has to be done explicitly. Okay, let's setting aside this thing. So here's the idea then. Now we have speaker defined like this. And so now my array of speakers is going to be like this. It's going to be an array of pointers to speaker. Then
yeah, sorry, go on.
Pointers to speaker. Then we make sure that everything that wants to be a speaker has a speaker field in it. So we give to person a speaker field, and we're gonna do the same to dog also later. So also dog needs to have a speaker. Then what do we put in speaker? We put a function pointer. So it contains a function pointer, and we point to our own specific implementation of speaking. So this needs to become const speaker, and dog speak is going to be the same. Let's call it dog speak. I'm changing their name so that it's clear when I say speak, it's clear which speak I'm referring to. It's going to be this one, and these guys are going to be all different. So let's give init to dog. So I'm going to need to implement init for dog. So dog is going to have a name. Returns a dog.
Oh yeah, sorry.
Oh, we have to do the item thing again. Item thing. So item. Okay, this is not going to be person speak. This is going to be dog speak. Dog speak is going to be different. We'll need to accept ctx. Well, as a pointer speak. Speaker. Okay, and now we need to fix the body of this function and the body of this function. So this is the thing that remains. Okay, now we have a pointer to speaker that is given to us, and we want to say, well, I have a pointer to speaker. Previously, the pointer that we were getting was always the beginning of the function, right? So we were casting the pointer directly to, the beginning of the struct. So we were casting the pointer immediately to the full struct. But now we don't have that anymore. Now we have a pointer to a field in our struct that could actually be placed in different places, right? You see how this speaker here is right after name. This one is after item. Maybe not. We don't know. Might get reordered. So basically, what we would like to know is whatever this offset is into the struct, we want to subtract that offset so that we can obtain a pointer to the whole struct. Does that make sense?
Yes. So do we have to manually construct this offset?
No, because we actually don't know that, because the compiler might, the compiler, depending on how it wants to order things, etc., it will decide internally what that offset needs to be. So we have to ask the compiler basically to do that for us. And so the idea is going to be that for in this context, to get a pointer to a person, we take this pointer ctx and we do field parent pointer. Field. Is it PTR? Yeah, field parent pointer. Given a pointer to a field, returns the base pointer of the parent struct.
Wait, returns the base pointer of the struct.
Yes. So let's say that we have a pointer that is going to be let's say that toggle exists in memory starts at offset 0, right? Then toggle dot speaker is going to be at offset 16 probably, because it's going to be after name, right? So field parent pointer will say, okay, speaker is at offset 16 within a struct of person, within a person struct.
Yeah, I think mlog is kind of catching on my reaction there. Is that the documentation for it? Because it was a little bit confusing. It at initial glance, it sounds like you're giving it a field and you're getting the address back of the thing that has the field.
Yes. I don't know. Let's see. I think that they auto-generate this stuff. So, whoops. Well, I have it here. Documentation. ABCD, EF. It's in the lang ref. Yeah, that's how it is. It returns the base pointer of the parent struct. I would say that seems all right. The pointer of the parent struct. Base, I guess it's not necessary.
So to me, it sounds like you're giving it a speaker, but you're getting a pointer back to the person or the dog.
Yes.
Okay, all right. So it is what it's doing. Okay. Then why would you do that? Why wouldn't you just take a pointer to the...
Because a pointer to speaker is what we pass around. Because that is the way we make all these things homogeneous. Previously, we were making them homogeneous by having a header implicitly always at offset 0. Now the idea is that what previously was a header now can be shifted around, can be moved. It becomes the speaker type, can be moved around. It doesn't have to be at the beginning of the struct anymore. But then we need to do a bit of pointer math, depending on where these common fields are, to go back to where the struct begins.
I would say we passed pointer math into pointer magic. Skylar's question is what I also have in mind. How do you know what the parent pointer is? Where does that information come from? Or is that a
okay, you have wait. Okay, let's do a concrete example, okay? We have toggle. So we have toggle that is an instance of person, right? So address 0 to 16 is going to be toggle.name, right? And then 16 to 32 is going to be toggle dot wait, let me do it this way. It's going to be toggle dot speaker. Does that make sense to you?
Yes, so far I'm with you.
Okay, so the reason why we can go from a toggle.speaker pointer to a toggle pointer is because we know that we have this pointer here. We have a pointer that points at 16. And then we have knowledge in person speak, in this specific concrete implementation of speaking, we know that we have a speaker that we expect to be embedded into a person struct. So we know that a speaker inside of a person struct is always going to be 16 bytes in. So we always want to subtract 16 for this type. For dog, it's going to be different. Dog is going to have dog speak. Yeah.
Yeah. So to clarify for anyone else who's with me, right? If this wasn't clear, that implies that you cannot call that function outside of the struct. You cannot call it on any pointer in the wild and just follow it to its parent.
That's the dangerous part that still remains. Yes, in the type system doesn't track the concept that speaker has to exist within a appropriate struct for this math to work. So if you
I think that was the confusion around. I can pick out the Rust programmers in the chat now, but I think that was the confusion because we were all confused as to how do you know, but you are using it inside the person, so you know it's the field of the person. It all makes sense.
Yeah, but you could, in theory, so since this type signature only says that this has to be a speaker, you could, in theory, make a mistake where you give a speaker embedded into a dog to person speak. The pointer math is wrong, and you read garbage. That could happen.
All right, I'm going to write this down. Do not embed speakers into dogs, okay? So there we go. Yeah. The dogs will be happier now. Okay, now that makes sense, right? So you could you call that function outside of a given type? Can you call that on any pointer?
Can you call that function from any given type? Which function, sorry?
The field parent pointer. Can I call that inside the main function?
Yeah, because it's not the fact that we are in this function. So maybe let me do it like this. Let me do it for dog. So what is actually defining what field parent pointer does, with which math it does, is this type here. Is the fact that we're trying to obtain a pointer to a person. So it doesn't matter. It doesn't matter where we are. It's not the fact that we are in this function that implicitly means that the parent is going to be this type. It's the fact that we are trying to, like an older version of Zig. Zig recently has started making it so that these built-ins implicitly also obtain this as a parameter, in a sense.
Okay.
Like another version of this function used to be like this. So actually, I don't remember if you made it a pointer. Maybe not, but no, I don't think you did. But you would usually, like in the past, it worked like this. You would say, I want to take, I have a pointer to the speaker field of the person type. And so this takes this pointer, subtracts 16 or whatever is the appropriate number, and then gives you that pointer. Now this parameter is not repeated anymore. Instead, it's detected from this.
Okay, that makes sense. I think Amlog really wants you to read something. This is why I have a reread redemption in my chat, which I never read. What do you want?
If Loris removed the star const person type annotation, he will get a compiler error. Do that and it will appear in ZLS. Will it? Let's see. Nah, ZLS doesn't give a fuck. I think we can trigger this error. Let me make it work correctly once though.
Yeah.
We haven't. Oh wait, we also have random errors elsewhere. Oh no, we have a bunch of errors. So okay, let's fix our random stuff. Okay, let's see if ZLS complains. Yeah, it complains. Field parent pointer must have a known result type. So you know how in Rust, I believe you don't have to specify the type of things, and then subsequent use defines what the type of the original thing was supposed to be.
If you can infer the type at any part of the way, it will do so. So you can infer the type from far down when you know. Yeah.
Zig absolutely does not do that, but it has a hint of it in the ability of built-ins to observe the expected result type. So think of it as a very minimal version of that.
Yeah. No, I think Rust puts a lot of stock in the type system. The type system is very front and center there. So I kind of get why, because it helps a lot with the like having a strong type system is really, really convenient when you do things as well.
Let's see if we can make it actually work. Missing struct field speaker. Right, I undid a bunch of changes, so we're back to not using init. Next, let's see. Expected type const interface speaker found a pointer to person. Right, so now we don't put pointers to toggle anymore, but we do toggle.speaker and loris.speaker. And so now we're putting pointers to our respective speaker fields in here, and it's fine. And we got UB. Aha. I did something wrong. Let me double check what's going on.
Oh, let's see.
Oh, wait, we have these. Yeah, we have this old stuff. We have the thing. We still had the old code that assumed that we could pointer cast these things into slices. Yeah, this is the old
now
code.
we don't need that anymore, do we?
Yeah, no, we don't. It's still here because it was the old stuff. Now what we want is s.speak.
Hey, there you go. Very nice. Very nice.
Yeah. But the problem is that, you know, this is a bit tricky because it's easy to make mistakes. I would say it's better than having. There's two things that are better, in my opinion. One is that it's better than having macros everywhere like you have in C. It makes it easier to compose multiple interfaces within a single type because in the C version, you kind of needed some coordination, right? Let's say that you had a bunch of types that needed to implement two interfaces, then you needed to, you need to know that to get to the second interface, you needed to go first past the first interface that was like at the very top of the struct. So you needed to do this kind of stuff. Here, it's much easier to have a type fulfill multiple interfaces. But look what happens if you do this. Whoops.
Oh, shit. Yeah, because What
Oops.
what does this do? Are you moving the speaker or copying the speaker out of the
I'm
struct
copying.
now?
Yeah, I'm copying the speaker field in an array of speakers. Yes, and now they exist in here.
And following that, well, it's no longer a pointer, but following that pointer would be obviously go nowhere, right? Oh, unfair lock. It's not happy. Now that makes sense, right? That makes sense that it is like that. And I would say if you have programmed Rust for a long time, at least you wouldn't even think about doing that, because you would think about the. I said it moves the data. I don't actually know what Zig does, if it's going to move or copy the data over, but you would know that you have lost touch with the underlying object when you do that, right?
Mm-hmm.
So that kind of makes sense. I think if you're a seasoned Rust developer, you wouldn't even try to do that, right? You would use references, or you would move the speakers themselves in there. But so that's an interesting way of thinking. So in Zig, you kind of operate on going from like an anchor point to the type that you want, and we made speaker this anchor that we can then follow back to the origin and make that the argument. So we kind of bouncing back and forth a little. We go back, we fetch it, and then we pass it in, right?
Yeah.
That's kind of that's an interesting take, because I think as it's kind of, you have to think in both directions. As programmers, it's easy to think about just moving one step forward, but here we're kind of going back to fetch something and bring it forward. That probably is more of an analogy or a metaphor that works in my brain, and no one at all followed me. They're like, "What was he talking about? Is it chicken again?" I don't know, man. So, all right, but so Skyler says, "Isn't that in Zig all types are copy?" I don't believe that could possibly be true, right? Surely you wouldn't automatically copy large chunks of data from the heap, right?
Well, this is the key aspect of understanding when something is a pointer or it is not. When something is not a pointer, you're referring to the entire original thing, and you are copying that around. Yes.
Okay, so if I put like 1,000 megabytes or a gigabyte on the heap, and if speaker was that, would I now have made a copy of the speaker into the speakers?
Yeah, you would have, but
okay,
but that's not normally the case. Like
right.
when things are huge, like in Zig, you work with pointers explicitly, I guess, more often than Rust ? I'm not sure how explicit you guys are with regards to pointers, but the general idea is that you just use pointers more.
You do, but of course, when it comes to pointers, there are the cognitive load, right? You have to in Zig, you have the defer to solve that. In Rust, we have kind of lifetimes, and you're adding to that. So what we've been doing here today has been pretty straightforward, right? We can very comfortably pass in pointers because we're operating on the main function. We're not crossing boundaries into other modules or anything like that, right? So no, absolutely. I would. What you've done here, it wouldn't be too dissimilar in Rust. We would use references instead of pointers, but we would have references to, instead of speaker would be a trait or an interface in some parlance, right? And we would pass references to these interfaces instead. But in general, we wouldn't have to do the plumbing, but yeah, in general, it's kind of the same thing here. We would have, and so actually, what happens if no, forget that. Interesting. Okay.
There was a comment from Amlag that I think is interesting. Fun trivia: we will hopefully have runtime safety for this feature for this in future via Witchcraft. So you remember when we mentioned in the beginning that structs in Zig don't have a well-specified memory layout? Here's one, I don't know, maybe a little bit simplistic, but like a hypothetical way in which you could implement a runtime check to catch this kind of mistake, so that you get a good panic that tells you what you did wrong instead of this.
I have to say, so I mentioned this before. I did a Zig programming stream a while ago, for those of you who don't know. And the amount of Zig that I've written before that was very minimal. And I was on Zig version 0.7. And back then, the error messages were a little bit jank. So I have to say the error messages in Zig has come a really long way. This was one of my biggest gripes with Zig back then. It was like the error message, because Rust at that point had already quite mature error messages and very like nice, here's a picture of a flower, you fucked up, and here's why. And it was all very like friendly, whereas Zig kind of just went like, oh my god, here's something in the standard library that you have no idea what it is, and it's broken, or it's not the thing that's broken, but you broke it with your code, kind of thing. No real issues. We're gonna change to something else soon, right? We're gonna become fitness influencers next.
Yeah, let's go.
But so we haven't really gotten to interfaces just yet, right?
Well, I mean, sorry, you mean vtables? Yeah, we haven't gotten to vtables yet.
So when I say interfaces, what the type of allocator is?
Yes. Yeah, that would be vtables. Well, actually, you know what? The type of allocator used to be this. Originally, allocator used to be an interface implemented exactly how we implemented speaker right now.
Okay.
Precisely like this. It contained, I think, 3 functions, maybe. What is it? Alloc, maybe 2. Alloc, realloc. I don't remember, but like this is exactly how it was implemented. This is old style allocator interface. Then we changed that to vtables. So yes, that's what we're gonna do next. But here's, let me just say one thing about this mlag thing. So he's saying that there's plans to add some safety around this thing to catch when you're doing this. So here's how it could work. I mentioned that structs in Zig don't have a well-defined memory layout, right? So that allows the compiler to add secret fields to them, make them fatter, put more data in them. So one thing that the compiler could do is somehow understand that this speaker type, since you call field parent pointer on it, you're making an assumption on where it is embedded, right? So what it could do is that every time you create a speaker, this also secretly writes down like the pointer of the parent struct, like hidden inside speaker. There's also a secret field that says, here's my expected parent pointer, or something like this. And then whenever you call this function, then it checks, whenever you try to copy it somewhere, there's a check that says, wait, this is a struct that has this type of property, and so the copy is bad. I don't know. That's probably an awful way of explaining it. I don't think it would just work like this, but you get the idea, right? You can stuff secret information inside a struct in debug mode. This is what the way it would be for debug mode, or maybe also release safe. I don't know, but it wouldn't be necessarily for like an efficient way, for an efficient build. But you could do tricks like that.
So you would attach additional type information. And I'm guessing this would be still aligned with what Zig is doing, because if you ask for the size of a type in release mode and in debug mode, you can get different values, right? Is that about right?
Sorry, can you repeat that?
If you ask for the size of type in release mode and debug, you can get different sizes.
Oh yeah, absolutely. Yeah, anything that relies on like being able to copy or make enough space for a thing, then yeah, we'll get different numbers and it will work out. Yeah.
Okay, I have some things I want to talk about, but I do want to see where we're going with the vtable before we.
I'll tell you, vtables are actually very fucking boring. Like the cool stuff we did just now, vtables are like just a more boring version of this. This all that we did up until now is a bunch of like I don't know, sorcery, so that our interfaces can be just single pointers, right? An array of speakers. This, like the correct version of this, is just an array of pointers. And vtables, instead, basically they say, well, let's not make the interface just a pointer. Let's make the interface a bigger struct. Let's not try to be clever with pointer math to derive a pointer to the function implementation and the data pointer. And let's just explicitly bundle those things inside a struct that you can copy around. So you know what? I'll do it, I guess, at this point. So speaker now changes and becomes this. So speaker, now it's a struct that contains the pointer to the whole data, a pointer to the function implementation, and then it calls the function implementation by passing in explicitly a pointer to the data.
You still have to do like the manual casting then at the implementation side of the speak function. Like
yes.
the person speak,
Yes.
for instance.
Yes. So here, let's see. I'm going to create a speaker. Now, I think this is now more annoying because I don't have a pointer right now. If I try to put, like, what do I put for CTX here? Because it's not immediately obvious what should go in there.
No, this is really interesting because you need to pass a pointer to self, but aren't you about to move self out of the function? This is my Rust brain talking again.
Result value, result location. We have this. I don't think we have
this.
No, we don't. We don't have that. We don't. We don't.
No. Wait. What is result location? You have to show this now.
We don't have that. You're going off the rails.
No. Logo. We're gonna look at what is result location. Is this a magical
thing? It doesn't exist. It doesn't exist.
Okay.
Wait, you don't store speaker in type. You create it in speaker function. Wait. What am I missing? You don't store speaker in type. You create it in speaker function. Yes. We don't store speaker in type. Yes. Oh, you're right. I'm dumb. Right. It doesn't have to live there anymore. Yes. So pub function speaker. So we have a function to create a speaker. Right. The at this point the struct doesn't need to live in the type anymore. Speaker. So p.
So while you're typing that out, I'm going to ask confusing questions to the chat as well.
Right.
In Zig, do you have such a concept as move, or is everything simply copy and you cannot move anything once you've created it?
Toggle, what is move in terms of what your computer does?
I guess you would take and copy some memory somewhere and then free the previous location. Or you would, in Rust parlance, that would be something more, I guess it would be something more specific, like assume ownership of something.
Right, but a move doesn't change the pointer of something, right?
Moving, sorry, say that again. A move doesn't change the...
Like if you have a value and you try to print its pointer and then you move it somewhere else and then you try to print its pointer. No, actually it might, I guess.
Okay. Let's say, well, I was gonna get to this one later. I have like a few things I want to get to the details thing, but
I'll work on this code in the meantime. Yes.
Okay. So what if? Okay, this is gonna be spoilers now. But if you have something like an allocator and you store values in the allocator, they live there. But when you can't fit anything else, then you have to reallocate. You have to move everything to a new memory address and so on and so forth. So you subsequently move the values, right?
I guess my point is that move is not really like if you look at let's say assembly, it's not a concept in assembly, right? I guess my point is that copying is something that copying or referencing something by pointers has an explicit meaning in what the machine does. While moving, I think, is like an abstraction, a conceptual thing that you do in Rust that then behind the scenes is going to do potentially different things, maybe copying, maybe not, I don't know, on the original value. And I'm sure that the semantics are designed to make sense and to make sense with what the machine ends up doing. But we tend to not have this stuff in Zig.
But you do have the fact that things can move, right? In the case of the heap allocator, right? You reallocate to a new place and you have subsequently moved the value.
Yes. So bytes. Yeah. Okay. Reallocation moves stuff around. Yes, but in that sense, it moves in moving as in okay. So moving as in moving in a different location in memory. Yes, that's kind of well, yeah, sure. But sorry. What is the I guess the next implication that you want to talk about from that?
Sorry, I lost track of what we're talking about. I'll try to remember now. What was I saying? Because because pointers, right? Yes, and I was wondering about this thing. When you create something and you return it from a function, does that mean that you have 2 copies of it? No, because you will invalidate it when the stack frame, that is the function that creates it, ends.
When you pass,
okay, that makes sense.
When you pass something to a function, you create a copy for it. When you pass something to a function, you create a copy for it. I guess the answer is, let's say if you think about something simple, like let's say just a simple number, okay? So to pass a number to a function means that you need the number to be in the correct register, right? I don't know, it was A0 in RISC-V. I'm sure there's like an equivalent in the other architectures. What are the default registers for function calls in x86? Maybe people in chat remember. I don't remember the names of these things. But I guess
yeah.
Okay, let's talk about something simple. Okay, like just a number. A number for a function call to happen. A number needs to be placed in the correct register so that the function knows where to expect it to be. RDI, RSI, RCX. Okay, so if we're just passing one number, then for a function to receive a value, it needs to be in RDI. So then the next question is, how do you get that number into RDI? And it might be that whatever your function is doing, that value happens to already be there. Or if it's not there, then you put it there with an instruction, maybe reading it from memory or copying it in there from another register. So I guess passing a value in practice means just placing it in the right register. And that might imply a copy or might not, depending on where that value was before and how how complex the value is. Maybe if it's a struct, yes, it goes on the stack. So you need to place it in the right position on the stack. And then the other function will pick it up from there.
Okay.
So I guess I would say the concept doesn't map really well, because the concept is like a higher level abstraction that hides a bunch of mechanics that don't necessarily have to have the shape of a move. I would say copying is a much more universal concept than moving.
Yes, but moving is not necessarily about moving the value, right? But that's kind of what I was thinking about, right? So the reason I asked that I brought this up was what happened
when a reallocation happens.
Yeah, so take for instance the init function there. If you were to pass a reference to something, basically a self-referential type. So if the dog had a reference to its own name, how would you go about that? Would you just initialize it with a null pointer, and once you have the dog return from the function, you would then assign the name?
Ish. The way you would do it when you need something like this usually works like this. You basically do this. Let's say that I'm in the main function here. So you do var. I don't know, spot of type dog is undefined, and then you do spot.init. But then the init function has a different signature. The init function will be like this. D. And then it's going to be d.self ptr or whatever the thing is going to be equals d dot name equals whatever.
And what happens if you copy the dog? Does the self pointer point to the original dog?
Yeah, the pointer doesn't
and
update automatically.
but that makes sense.
Yeah.
I don't know any language that will automatically, without any influence, update pointers. I don't think any language does that. There might be some magical pointers in C++ that does that.
It has to be a language. It has to be a language with a runtime. Like Go works this way. In Go sometimes needs to move around the stack of a Go routine. Because so Go routines in Go literally have their own stacks. So there's like in the heap, there's gonna be these chunks of memory that are used as a stack by Go, like a stack by Go, and they will need to be moved around because they grow too much and they don't fit anymore where they are. And Go will literally copy the data somewhere else in memory, and then use its knowledge of runtime type information to go and fix up every single pointer in the Go routines memory.
Wow. So if you were to copy a dog in Go with a self-referential value, that would actually update the value to point to the instance rather than the origin?
Oh, that's a good question. What happens if you do that? Maybe you know what? I'm actually not sure. I know that the runtime can do that correctly. I have no idea. I have no idea what Go would do if you have a pointer that you put yourself there. I would assume so. Yes, I would assume that Go knows how to fix up that thing. But also now that
is kind of insane and also very nice to be able to just not worry about your code like that. So you can have a bunch of pointers into your own types and they will just work. That's just I wouldn't assume that is the case of any language, but of any non-garbage collector language. But that obviously comes with an overhead.
Yeah, there's a price.
So it would make copying dogs around more expensive.
Okay, we're almost done with these vtable stuff.
See, this kind of makes more sense to me rather than following a pointer to the parent, even though that made sense to me as well. But to just casting the pointer, because now now that's all we're doing. We're just casting a pointer from one type back to itself, right?
Yeah, because now we're passing both of them. This is not vtable yet. What am I missing? God damn it! It is. Come on. Am I missing speaker? No. Oh wait. Okay, so this is gonna be dog. I copy pasted it from person.
So now the speaker holds two values.
Yeah,
it holds
and it can be moved around. With vtable, you would store a pointer to vtable instead of speakfn. The thing you're missing is the actual vtable, but that's completely pointless if you only have one function. Yes. So basically, with the vtable stuff, you have multiple functions. So the vtable is another struct that has all the function pointers in them. So yeah, I'm simplifying this slightly, but I guess the key aspect of this is that now previously speakers were just pointers, right? A speaker interface was a pointer to the correct field of different struct types. Now speaker is a struct type that you can copy around, and copying it doesn't break anything. Now this should work. Let's see if we can make it work. Okay, I need to fix some things. Let's see. Expected type. I need on line 8. Next, expected type. Oh, do I have a few of things of these that are missing? Line 8. Line 8. Line 8 any opaque. Let's see. Let me read it better. So, what's the problem with dog speak? Align 8, const opaque, const u8. Expected type. Why was that the expected type? Speaker. Wait, that's an old error. Oh yeah, and dump. Oh yeah, I fixed I fixed too many of them right away. Okay, let's see. Expected type, align 8, const opaque, found const opaque in speakfn. Oh, right. We need to change this. Let me see. What's the problem? Found const opaque. The CTX field type. What did I do wrong in there? Oh yeah, it's not aligned. There we go. That works.
There you go.
So we got it working. So this is not hello files file.
So really what we did at this point is we create a struct that has a pointer to the data and a pointer to the function. And then when we call the function, we pass the data and the function to the function
so
pointer.
We stopped trying to be
sense.
we stopped trying to be clever about pointers. We dropped the requirement that this thing needs to be embedded in the original struct. And so we got it. Like, let's look at
this is not a V table.
Yeah,
okay, so
they're
what are we
stuff.
missing for this to be?
Let's look at the real implementation. Let's look at SDDMem allocator. So you will see that SDDMem allocator, it's basically very similar. You have PTR, that's what I called, what I previously called CTX. So this is pointer to the data. And now the difference is that vtable is basically, instead of having only one function that is decided by each type, so instead of having just person speak and dog speak, vtable is usually a struct that contains multiple function pointers. So this one will contain, so to implement the allocator interface in Zig, your vtable will need to contain a pointer to an alloc function, a resize function, and a free function.
So is Andrew, is the only difference between a vtable and what Christoph made that Christoph doesn't have multiple functions?
Yeah,
or
that's it.
Is it all the functions? As we have 3 functions, it stores a pointer to those 3 pointers. It doesn't have extra indirection. Okay, I'm unsure what that means.
Yeah.
What's the extra? Is the extra indirection that it would be stored in a collection? So we have to go to the collection or the storage and then look up the function.
Yeah, look at this.
Is that it?
Look at this. This is the more complex version of my speak, right? So let's look at my speaker. My speaker has CTX, which is like
the pointer.
It was called PTR in the other one, and I have my speaker function right away.
Yeah, and we're missing an indirection, so that speaker function should have been stored in another storage that we would have to go to. Okay, I understand.
Every type would have its own storage, and then the idea is basically, let's say that you don't have only speakfn, right? You have 10 different functions. If you inline them directly into this struct, then you will have to move. Your interface becomes fatter and fatter. It becomes bigger and harder to move around as an interface. So by having an extra indirection layer, you can keep your interfaces small like this, but then you have to go through another pointer before you can reach all your function pointers. So you're trading an extra level of indirection to keep your interfaces smaller.
Okay, I understand. So technically, this wouldn't qualify as a vtable, but the principle is the same. For this to be a vtable, we need to add something like a hash map, mapping function names to the function pointers or something like that. I don't know.
It doesn't have to be an hash map. It can be just another struct. But the point is that, like here, as you can see, it's a struct. A hash map, well, the idea is that the shape of these things is set in stone. So you don't need that level of dynamicism that a hash map has. But it would need to be a struct stored somewhere else, and then you have to go through that pointer to access that struct, and then only then you have access to the function.
MLog wants you to make this into a hash map, and that's the only thing he wants to see now.
Yeah, but don't trust MLog.
Oh man, I don't know, man. Yeah, it does seem a bit sketchy with a hash map thing, right? Okay, so yeah. One thing that we never talked about, or we never concluded the conversation, and I think the conversation is interesting. So I'm thinking about Zig from the perspective of Rust programming, right? And one of these things are in Rust, you can take a reference into something like a vector or a dynamically sizable array, whatever you want to call it. You can take a reference to something in there, and then you can try to add something to it, but you can't do that. The compiler will prevent you from doing that. because you could potentially move everything in the vector. Coming back to what we talked about earlier, so if I have a pointer to an address and whatever is at that address moves, how does Zig deal with that, right? What happens if you do that?
I think I understand where the source of confusion might be. So let's, I don't know, let's get rid of our speaker stuff.
We can just make an empty or collection of some data, something that can allocate more data.
Well, we can do it like this. So, have you ever seen heap allocation in Zig at all?
No, I have not seen. Not this year or the previous years. 0.7, I did something with allocate and allocator and deferred, maybe.
Okay. Then we're gonna do this for the first time. Let's go. Because I want to show you proper reallocation, right? So we're gonna do that without any collection in between. We're gonna do that with just strictly using the allocator interface. Which is what would happen behind the scenes if we were to use like the Zig equivalent of a vector. So let's say that I'm gonna do this. I'm gonna do const. How do we do this? Let me think. People.
It can't be const. That much we can start with, right?
Oh no, it can. It can.
It can. It can.
Wait. Yes, it can. So I'm morphing into a person myself. Or yeah, I'm. You know what? No. We now both get to be dogs. So we're now both dogs.
I do feel.
What do you want to have? What's your item? You can have the brandy if you want. You decide.
Well, I'm gonna. Can I have what are my options here? Right. Okay.
Options are berry, potion, brandy. I can add another one.
Oh well, I did have some berries this morning, so I can have some berries though.
Okay, you can have a berry.
That's. I mean, most dogs carry berries, right?
Okay, then I'm gonna switch to potion. Okay, so you have a berry, I have the potion. So we're creating. So it's not people anymore. Now it's dogs, doggos. Okay. So here's how I'm gonna do it. Actually, wait. Before we get to this, we need to create an allocator. So let's do the boilerplate to create an allocator, a general purpose allocator.
And drop it in 2 lines, right?
I think it's going to be 3 lines, but yes. So the allocator needs to be var because it has internal state and it needs to be able to mutate. So I'm going to call it GPA impl. And it's going to be a std.heap.general purpose allocator. General purpose allocator is a generic type because it accepts GPA state. I like it. I'm gonna switch it to GPA state. So it's a generic. It has a bunch of configuration that you can use. That you can pass it to change its behavior. For example, the testing allocator, which is the allocator that you have access to inside of a test block in Zig, it's actually a GPA configured for extra diagnostics in order to report leaked memory or double freeze. Is the GPA just calling malloc every time you allocate? Depending on how you interpret your questions, the answer could be yes or no. So the most strict interpretation is no. GPA does not call malloc because malloc is a C function implemented inside of libc. But both GPA and malloc are general purpose allocators, meaning they behave in similar ways overall. You create individual allocations, the allocator tracks individual allocations, and then you can free individual allocations. So in that sense, they are similar. But no, GPA does not call malloc. Malloc is a userland concept. What both GPA and malloc do is that they both call mmap on Linux and macOS and virtual alloc on Windows. Although not every single time. They do so when they need extra memory in bulk from the OS. Okay, so GPA state is going to be this guy, and then we init it. And I don't think we need to pass in any argument, right? I don't remember. I think I don't. Okay, so then defer GPA state dot the init. It's not a function. Oh, right. Wait, it's a config now? It's a static. Wait. Const init. Holy shit! Right. Let's go. Then the init. I think the init returns a value that we want to ignore for now. We don't care about the result. Although checking this result is what is going to tell you. This is how you can then get information from the allocator that some allocated memory was not freed, for example. Okay, so we're going to ignore it for now, and then we do const GPA equals GPA state.allocator. So GPA is the allocator interface, just like we did speaker earlier. Now we're doing .allocator. Okay, we're finally ready for the prem time. Doggos. Let's make an array of doggos on the heap. So we're gonna do GPA dot alloc. The type is gonna be dog, and we say how many dogs we want. In this case, 2. Now, doggos. Toggle. Try to guess the type of doggos.
A slice of dogs. Is that right? An iFace dog.
Expected type. iFace is the name of the file. It's called iFace.
Oh, I see. Okay.
Yeah. So it expected a dog, and we expected to put dog, and instead, well, so the type that you gave was almost right. To be precise, since we didn't put try, the result was an error out of memory, potentially, because we could be out of memory. Or, yes, you got the type right. It is a slice of dogs. So
so we just have to do a little
we just put
try
it's
there.
fine. Yes. And so now now it works. Oh, it complains about leaks? Wait. Why is it complaining about leaks? I mean, fine, but I didn't ask it to. Yes, I know. I have my standard library is poisoned with a bunch of print logs. So I'm gonna go remove them, but in a moment. But so this default init is actually turning on a bunch of checking behavior, huh? The init always complains about leaks. It's in the config. Oh, I see. Wait, is that the case? I thought you had to explicitly accept the return value and check on that to get this stuff, these complaints. Huh. Well, guess what? Then you're catching me. You're catching what my general memory management strategy is. Okay, so it's okay. Let me remove my debug prints from the standard library. That is on me. I was testing stuff yesterday, and I did that. So std.debug.dwarf.
Oops. You're gonna need this then, right?
Yeah, no. This was me editing the Zig standard library. So ignore that. Okay.
Oh yeah.
So it's telling us that we allocated dogs and then they leaked. If we make a release version of the program, it doesn't care about that anymore. In release mode, GPA doesn't care about us leaking. Okay, so
the operating system is going to clean that up anyway, so it's fine.
But in the bug, it's like good information to have. Okay, so how do we make this happy then? We do defer doggos. We do defer GPA dot free doggos. So if we do this, now also in debug mode, we're happy because we created them and we freed them. Okay.
So now we can add these now, yeah?
Yes, so we can do doggos 0 equals toggle, doggos at 1 equals Loris. And then we can do for doggos.
So the allocator is effectively a collection. Then these are kind of closer to what the Bumpaloo and such are doing. Interesting.
Come again, sorry?
No, so the allocator is a homogeneous collection in that case. So it is closer to...
not exactly. What's happening here is that we got out of the allocator 2 dogs, but down below we can ask it to give us 2 people. So so the slice of memory that we got is homogeneous because it's an array behind the scenes, right? It's a buffer and it has to be of homogeneous types. But then the same GPA can give us whatever we want. Okay. Let's see, what did I do wrong? No member function named dog speak. Oh, we still have weird stuff from before. Dog has dog speak, but it's also weird. Okay, let me implement back a. Actually, no, we can do .speaker.speak. So we still have the interface machinery going on. So we can still do dog.speaker.speak. This should work. Let's see. No name field CTX. Oh no. And I renamed this to PTR. I broke some things, maybe. Let me see. Interface.
Right, sorry, I missed a little bit of that. I got a phone call. I've run out of time. So the question is, and I probably I get enough time to see what happens with the movement thing though. When we reallocation strategy, let's see how that works.
Okay. Well, the way that works is that when we ask for that, we do that explicitly. So this works now. Let's move them. To move them, what we need to do is it's a GPA.realloc, and old memory is going to be doggos. New number is going to be, let's say that now we want 10 doggos. So normally you don't just ask to move because it's not useful to move data. Usually what happens is you ask an array to grow, but then there's no space there. And so for it to actually grow, it needs to be moved somewhere else. So the reality is that we cannot ask the allocator to move it necessarily, unless there's some flag somewhere, some extra option that you can pass around. I don't know if we have that in our interfaces, but normally you don't ask for stuff to be moved. You ask for stuff to grow, and that might constitute in a reallocation. So as I was saying, you say, I want 10 doggos now, and guess what happens? That gives you new doggos. So let's say that we make this var now, and you do it like this.
Okay, so yeah, I'm really curious what happens with like line 14 and 15 there.
So the way it works is that we have the original location, we write to that memory, but realloc also copies the original stuff. This function requests a new byte size for an existing allocation, which can be larger, smaller, or the same size as the old memory allocation. If new line is 0, blah, blah, blah. Okay, realloc will also copy the memory. So if we run it, or I think it did. Did I did it wrong? Realloc copies the memory, right?
Yeah,
maybe it does not.
But you are printing out. You said give me 10 doggos, right? And we only have 2 in there.
Oh yeah, right. Yes, of course. Now the other doggos are garbage. Yes, of course.
But here's the thing, right? What if you took a reference to it before you allocated? Are you allowed to do that?
Let's say that we have the original doggos, and this becomes new doggos, right?
I mean, arguably, you should be able to take the reference before. Well, I guess that's just going to copy the value, right?
Well, I guess what I'm saying is that we have this old... This is a pointer to the old memory. Previously, we were updating it, right? Previously, everything was fine because we reassigned the doggos to the new value that we got from realloc. Now, we're not doing that anymore. So what could happen is that realloc moves the memory, so it needs to create a bigger allocation somewhere else, and so now it can't. It has to move it somewhere else, and so now the old pointer is going to be garbage. In this case, going from 2 to 10 doggos, it's not going to be a problem. Like I suspect strongly that we run this. Never mind, we're getting a seg fault.
Okay, so the long and short of it is you can have the old memory there. You can refer to it, but
it's gonna be bad memory.
It's bad memory, right? So okay, the only thing that doesn't gel with my thinking now is that, and it's probably because we talked about copying so much. So in my head, that would just copy the dogs over to the new one, and the for loop should still work because of the old ones. But when we do a realloc, does that call the deferred function of freeing the doggos?
No, it doesn't call anything. It just manipulates the memory. That's because we don't have RAI. So if those doggos, generally speaking, moving things is fine. When it is not fine, usually, I guess you would have to manually make sure to call any deinitialization function before moving stuff around. If you consider the new ones, before moving stuff around. But
I had lots of more things, not lots of. I had a few more things I wanted to talk about, and they're like quite big conversations, right? I have to run, but I think it was really fun to do this, and we should definitely do this again.
I'm sorry we lost so much time on touching chicken stuff, and
I think that this stream would have been rubbish if we had not talked about touching chicken. I think touching chicken made the stream. But that said, I want to do this again. I am gonna go and cook my family. No, I'm gonna cook for my family and stuff. Maybe we'll figure something out because I'll have more things I want to talk about, and then we can deal with that, right? It was great. You guys have a wonderful day, and I'll catch you guys later. Bye for now.
You. Bye, Toggle. Okay, let me see. I'm going to disable all this stuff. Okay, we should be good. So so this was the thing. I'm trying to understand exactly what Toggle finds interesting about this mechanism. My guess is that what I think he would like to see done explicitly is understand that the allocator interface, like when you move something around or like do something that potentially moves stuff around, every time that happens, you're doing it precisely with talking about the one thing that you care about, and so that you get a chance to update pointers to it when you do this. And obviously, if you have random parts of your program that have a ton of pointers to random stuff everywhere, you might forget to update some pointers somewhere. But it's also, how can I say? It's also something that in practice doesn't happen too much, I think. Or at least you account for that. So you try to design around this problem. As far as I can tell, what's happening is that Rust and C++ give you terrible mental models for how memory works. I would say 100% for C++. For Rust, I think that the objective statement is that it gives you a mental model that is not very tightly tied to what's happening in reality. But with Rust, people don't make mistakes. Like with C++, people make horrible mistakes with memory, as far as I understand. With Rust, not so much. I think that with Rust, kind of the worst is that people overuse RAI. They do a bunch of, single item allocation, deallocation, and management. And so they end up with inefficient stuff. So I guess depending on how precise, how clever, how perfect you want to be in your expectations of how memory should be managed, then I guess past a certain level, it is a problem that Rust doesn't expose to you the real basics, right? Rust doesn't show you exactly what's happening at a given point in time, and past a certain level of like precision, that becomes a problem. For sure. But yeah, at least, yeah, I was about to say at least something. No, I'm gonna stop here. In any case, so this is it. It's definitely interesting though. What I think this makes it particularly interesting for me is that it means that there's a bunch of people who are doing Rust who are becoming proficient with Rust and are using Rust to make real world programs who do not have internalized how this stuff works, and that will have implications. So I think that every single time that people have pushed back on whenever I would I don't know claim or that Rust software with RAI is usually not all that efficient. I mean, now I'm starting to think that no, I was actually more right than people gave me credit for, because you can't design efficient software if you don't have a clear picture of what's going on here. Now, whether that is, how important it is, how necessary it is, that's obviously a different discussion. Not everybody necessarily, I guess, has to do these all the time. But there are certainly situations where this is important. One situation where this is important is when you're building developer tooling, for example. And so I sincerely hope that the people who are working on developer tooling written in Rust, like I'm thinking of, I went to a conference where there were a bunch of people from V0, I think it's called V0, like a bunch of people who were working basically on Rust implementations of tooling, like linters and stuff, and bundlers for JavaScript. Yeah, they were using Rust. And man, if they don't know how this stuff works really well, they're not going to be able to write a performant parser. Maybe they will still create a better parser than the equivalent implemented in JavaScript itself. It's still going to be faster, but it's going to be very far from the best you can do with reasonable effort. Zed became slower than VS Code once they started going hard on Windows support. What? Really? Brian, do you have a link where I could read something about this? That is mind-blowing to me. I mean, if this were a Zig application, every abstraction that you would build around the Windows stuff would pretty much be genuinely zero cost when you're building for Linux or macOS. Sorry if I'm stealing a Rust expression, but it seems surprising to me that adding Windows support makes Zed slower in general. What to me would make me think that Zed is taking a performance hit is, for example, adding one thing that they do with Zed is that to have support for language servers, they have Node running inside of Zed. So they have a full Node running because that's the only way they can run certain language servers implemented in TypeScript, because they're quote unquote still like they are using a bunch of LSPs that were written in TypeScript for VS Code. And so to have wider compatibility, they run all of Node, which is, well, not performant at all. But this statement really surprises me. Saw a lot of people complaining about Zed some weeks back. Well, if you have a link, I would be curious to check it out. Best part of Zig's explicit allocation model is that it has produced an amazing number of non-allocating libraries. Oh yeah. By the way, once you become really aware of this stuff, you get to enjoy trying to figure out how to avoid heap allocation when you can. And it turns out that there are so many things that you can express in a not heap allocating fashion that is mind-blowing. And so it's really fun to look at these problems from that perspective. Really gratifying. I saw the same comments on Zag becoming slower. Wow. Rust has a crate for just closing file handles in the background thread on Windows because Windows Defender is so slow. I totally believe this. Not surprised at all. But then again, the point was that Z became slower while adding Windows support. So the way I understand that is that the implication was that Z was not working on Windows before. Then it started working on Windows at some point, but then Z was slower not only on Windows, because that's a statement that you cannot make. Previously, Z was not working on Windows, so the first data point of Z running on Windows is you experiencing it for the first time after support for Windows was added, which means that the implication is that after this work was done, at least as I understood it, after this work was done, then it means that people using Z on macOS and Linux experienced slowdowns when comparing Z pre-Windows support and Z post-Windows support. That's how I understood the statement. And that is something that seems, well, something that just does not smell right to me. Not saying that it cannot happen. I'm saying that I believe that this can happen. And like, I believe people in chat saying that they saw comments about this stuff. I'm just saying that is really sus, like what's going on there. If that's the case, something weird is going on. We have sporadic CI failures in Zig because Windows Defender sometimes just decide we shouldn't have permission to read the files we just created. Nice. Wait, but why are you guys not turning off Defender on the CI? You could turn off Defender in our Windows CIs. See last message. This is with an exception marked in Defender for the CI errors. It occasionally just ignores that exception. Yeah, no, what I'm saying is just turn the entire thing off. I don't know if Windows 10 prevents you from doing that, but in Windows 11, but in Windows 10, you can turn off Windows Defender if you want, I believe. Huh. Sorry, I know that I haven't been chatting with you all about CI stuff in a while. But I think you can just turn it off. I tried learning Rust, but couldn't get my head around the language. I've been learning Zig for about 3 weeks, and I'm already comfortable programming in it. So refreshing learning a new language that does not have a mountain of a learning curve. Oh, it was a video comparing startup speeds, so I don't know how useful those comparisons were. Okay. So they were checking how long it took to load the application, not general speed while using it. That seems to make more sense to me. I would say it's still probably a bit fishy, but I guess I can believe that more. Or rather, I can believe, how can I say, it's, I guess, easier for that to happen. What's the best part? That's the best part of all in low-level languages, less mental overhead, so you can focus on fundamentals. Well, not every language is doing this, right? Like Rust is still a new language, and it's by design not meant to just give you a few simple tools for you to focus on fundamentals. It's more like of a heavyweight, all-powerful type system, a bunch of concepts that are specific to Rust that allow you to encode certain patterns in a safer way that can be checked programmatically. And so the idea is that the price that you pay for that extra stuff, you get returns from by having certain things checked by the compiler for you right away and through the type system, both in terms of like you making mistakes and also in terms of other consumers of your API getting access to somewhat sophisticated, well, not just somewhat, like getting access to sophisticated things like traits and stuff. So I mainly meant Zig C3 Odin. I see. Yeah, although, I would say that the fact is that these three languages, they all share a common lineage. like personally, I wouldn't say that this is a new trend. I would say this is something that is true of Zig, and that more recently C3 and Odin have also done themselves, because they both come from the Handmade network. So Zig doesn't come from the Handmade network. Andrew, I don't know, I guess has attended the Handmade conferences, but I don't know. I don't think he qualifies as a particularly active member of the Handmade network. So, or in any case, it's very different for him compared to the other two guys, like Christopher Lerno, who is the author of C3, and Ginger Bill, the author of Odin. They are much more active members of the Handmade network, or at least were in the past. I don't know, given the last events in the Handmade network, how things are going there. But in their case, they are striving for a kind of minimalism that puts them kind of close to C and some other languages in the past. Also, in a sense, I think that both C3 and Odin have also a even more simple type system compared to Zig. They don't have comp time, for example, at all. I don't know if I think C3 has macros. Odin just doesn't have anything. Odin, I think if you want to do some metaprogramming, it's either runtime type information, or you have to do code gen. Like you basically template new Odin files, source code files, by doing, I guess, quote unquote manual mode macros. It does have comp-time params and whatnot. You can do some similar stuff. Para poly. Is that Odin that has when? Mm-hmm. Parapoly is in parametric polymorphism. So we're talking. So it's still okay. So we're talking about we're talking about like generics basically. Yeah. Okay. So man, this was an adventure with Toggle. I feel like near the end I was kind of my explanations were becoming more and more imprecise and hard to come out. But I think overall it was fun. So yeah. I don't know. I hope that people got something out of it. I don't know. What would be the final lesson to be learned here? I feel like the final lesson to be learned here should be therefore, next time you should invite MLAG, of course, says MLAG. You actually want to do this? Oh, I see. No, wait, you want to replace me. Oh, I see. So you're saying you and Toggle, you should go say this stuff on his stream, not my stream, man. So let's see. I guess the general takeaways should be it is interesting to learn how this stuff works in a concrete fashion. You don't have to. You can get very far not knowing how any of this stuff works. But learning how this stuff works can be interesting. Some of these tricks have like they're like interesting trivia, I think, at the very least. And then there might be occasions where this stuff actually makes a difference. We weren't able to showcase that on stream, but I can promise you that if you write a parser and you don't and you do like you heap allocate every node in your AST as a separate allocation, and you use pointers to point from one node to the other, and you do everything this way, you will get much worse performance characteristics than if you were clever about it and used and you basically like linearly allocated everything in arrays, and you used indices into the array instead of pointers, and you use maybe what we call multi-array list in Zig, which is turning struct of arrays, array of structs into a struct of array. So you like DOD. For the web people, it's kind of like doing row-oriented versus column-oriented memory storage, like OLTP versus OLAP. It's kind of the same principle. So if you do tricks like that, you get dramatically better performance when doing things. So a lot of performance things are not really like, you know, the genius GNU programmer that is a wizard and only they know the magic way of making this thing super efficient. Maybe there is a little bit of that here and there, but you can get like very far. Like you can get huge wins just by having a proper understanding of this stuff, which is not super hard to get. Then I don't know. Then for the people doing Rust, I guess my recommendation would be don't shut yourself off from this stuff. It can be useful. Maybe you're not gonna use it in Rust, and sure, some of it comes at the price of potential undefined behavior. But if you don't have this knowledge in your toolkit, you're not gonna be a well-rounded programmer. You're still gonna have some pieces missing here and there. And, you know, sometimes that won't make much of a difference. Sometimes it might. Sometimes it might be the missing piece that you would have loved to know about that would allow you to, you know, be able to do real-time audio stuff in a way that you just can't do without this knowledge, because you end up with something that is too inefficient. And so you get like this skewed perception that your computer just can't keep up, even though it totally could if you just did it the right way. So yeah, I think I'm gonna, yeah, I don't know what to do with this stream. So I'm getting a little bit tired. I spoken for like 5 hours and a half already. So Togglebit has been there for a while. So I need to thank him. But yeah. So Mlag, I would totally be happy to join for real if you did want. I can even get, oh, you're saying right now. Holy shit, man. Oh, you know what? Here's what I would suggest. Let's do that another time where I can give you my full energy. Like, let's organize a stream one of these days when you come on stream and you do some of this stuff. Or you come on stream and then Toggle teaches both of us Rust. So that you can tell you that, you know, there you cannot resize that thing because it's borrowed somewhere else. I'm making this up, by the way. That's not how it works, probably. So you can't resize it because it's borrowed somewhere else, and then you're gonna go insane thing saying, "What do you mean? I know I can do it," but then the compiler won't let you. Yeah, that would be fun to watch. So my idea for Toggle, one thing that I wanted to try out with Toggle is to try and write a simple parser in Rust, and then try to do the same thing in Zig, and to see basically, you know, what are the things that you tend to stress in each language. Of course, you know, it like writing a parser. I feel like writing a parser with performance being one of the main things that you keep in mind as you're writing a parser. Which, by the way, not every parser needs to be performant. To be fair. Like, you would want parsers that have to deal with a ton of stuff, a ton of data, a lot of usage to be efficient. But you know, it's not a hard rule. It's not a moral thing for every parser to be fast. So that's fair. And of course, in this case, we would maybe focus on performance, which is more in Zig's wheelhouse, I guess. But still, it would be interesting. I think it would be totally interesting. Also because even though maybe from my perspective, it would be more in Zig's wheelhouse, I think that probably you can do all these things also in Rust. Maybe it's not the first thing. It's not the first way that you would think about going when solving the problem, but you could totally pull off all these things in Rust. And, you know, so for the one time that you need your parser to be efficient and performant in Rust, then you whip out the cursed knowledge and you do it. And then you have the best of both worlds. You have the safety and the easiness of things, like the ease of doing things when you need that, and then you can whip out the more advanced stuff when you need the few times where you need this stuff. So yeah, so thank you all for being here. This has been fun. By the way, as a small status update before I close the stream, I'm starting to get closer to being able to become a Twitch partner. I don't know exactly what that will like entail in my case, but I need 75 viewers on average, and once I reach 75 viewers on average, I'm gonna be able to get Twitch partnership. So I'm gonna get the blue check mark or whatever that is in on Twitch, whatever that means. So yeah, thank you all for hanging out, and let me see if there's anybody streaming that I can raid. Anybody doing Zig? Anybody doing Zig? Let me see. Let's see. What do we have in the programming section? Making a Celeste clone in Godot. That seems fun. C#, no. C++ game dev. Rust. ASMR programming. C-style, no game engine dev. You know what? I'll do the Celeste stream. I like Celeste. So have fun watching the Celeste stream.